Hello, everyone. I am here with zetamath above me and Math Pesto below me.
Hi, everyone.
Welcome, Math Pesto.
Thanks for having me.
It's great to have Math Pesto on stream, and I myself haven't been on stream in any capacity for quite a while. Let me know, chat, if you can read the rules up there. But yes, welcome, and a huge welcome to Math Pesto here.
Yeah.
Yeah, shade some cells. That's the first words. Welcome to everybody. Martin, Ambrose, Logan, Nell, Gwyn, great to see you. M. Nasty, Daniel, glad you made it. Afraid not. David Ratner, always good to see you. Dorlier, welcome. Plunk Time, heartfelt welcome. Welcome, Emma, Michael, Isabella. Great to have you all here. And yes. Great to... I'm really stoked to be on camera, and I'm really stoked to have Math Pesto here. And yeah, let's have an afternoon of puzzles, or evening, or whatever.
Excellent. And congratulations to AFK on the CTC feature today.
Yes. And let me know how our audio balance is, if I'm louder or softer than Zeta and Math Pesto.
And this is me speaking right now to test my audio.
It looks like I might be slightly louder than you two. There we go.
Okay, let's attempt to read the rules. So we need to shade some cells representing water. So I guess this will be green. Sorry, not green, blue. water's the blue one, right? This is off to a great start. The water cells form a single orthogonally connected region with no 2x2 area entirely shaded. Okay, good. Each orthogonally connected group of unshaded cells contains exactly 2 numeric clues. The 2 clues may occupy the same cell, indicated with a tilde between them.
Tilda.
Yeah, there we go. And one of those clues is the number of cells in that island. All clues are parts of islands. Okay, good. So we should
Zetamath.
start by what?
I'm not going to redo it right now, but looking at the example puzzle on LMD, there are no double bridges on the same cells. It's just 2 different bridges connecting.
There could be.
I mean, the rules say each pair of islands has either
figure
0,
that
1, or
out.
2 bridges connecting it. But
Right,
maybe
but I don't
the double
think
bridges don't need to go between the same cell or something. Because like it's possible that this was doable in Sudoku Pad, actually. But I was just thinking, like, I know Hashi has double bridges, and this does have double bridges, but it's possible that it will work out so that you don't actually need to do it. Let's see. Oh, okay. So we actually can do this in Sudoku Pad, although might as well now just do it in this because Nell points out the rules. Actually, if I actually read the rules, I did not actually read the rules. I just skimmed to be like, Hashi's the one with double bridges, right? That was the extent of my skimming. So yeah, so actually it would work in Sudoku Pad, but that's okay. We'll go ahead and officially green all of the clues because it says that. And each island contains 2 clues, so we can blue this stuff like that because the blue is all connected. Oh, this 1, 1 is the size of the island. So we can even actually do that.
I think we could have a few of those not be. The corners could be green, right?
These corner. Oh, that corner.
Yeah.
The water is a single connected region.
Gotcha.
So I think that means that. So yeah, this one also we can do.
Well,
This island. Yeah, that one has to be because the water is connected to water.
oh, right.
And this island also is done because it can't have a 3rd clue, but also one of these 2 is the size of the island, so we have to do that. Okay, that might be the end of the. Oh, I guess I can separate that technically.
Yeah.
Oh yeah, the 2, 2 can't join any of those things. That's true. This island doesn't have 2 clues yet, I guess. But it can't have 3 clues. So I guess we get some more stuff even. We haven't even like finished reading the whole second half of the rules. But just from what we've learned so far, we have gotten some things. The other clue in each island is the number of bridges connecting that island to other islands. A bridge is a straight line from a cell on one island to a cell on another island with only water cells in between. Bridges cannot change direction, cannot cross one another, and cannot start or end on the same cell as another bridge. Each pair of islands has 0, 1, or 2 bridges connecting it. An island may have bridges to any number of different islands. The bridges must join all the islands into a single network so you could travel from any island to another island by crossing a series of bridges. Okay, so now we know that. So this island must have size 3 now, so we actually can blue both of those because remember, one clue is the island size, and then one clue is the number of bridges. And we might be done easy stuff.
So let's see. The 4, 1 clue, the 4 can't be the bridges because you'd have all bridges emanating from one cell. So that island has to expand. Not
agree.
Helpful yet.
Yeah, it has to expand, and there's lots of cells it can't grow to. I don't quite have a like multi-select mode. This 6 actually is going to be a little awkward in terms of what it's going to have to get to. So this island, so an island with a 6 on it per your observation has at least 6 cells, because the 6 could be the bridge, in which case then it's got 6 cells with bridges on it. So it's almost assuredly going to connect to the 7, but I guess it could connect to the 3 maybe.
And the 2 clue below the 7, that can't be just a 2-cell island, because then it wouldn't have a bridge clue connected.
That's true. So this has got to find an island. Actually, can it find an island other than this? Oh, so
it could be the 10 or
yeah, the 10. There we go. Yeah, the 10 is kind of messy. I guess this one over here, actually, we can make the same kind of observation. That this one has to grow because, of course, it's not done. But then there's some concerns about like exactly how does it grow, I suppose. Let's see. This 2-cell island we know grows in exactly one direction, left or right.
And there's probably not a way to notate this, but each of those cells is going to have a bridge. But we don't know which direction yet.
If we were doing this in Sudoku pad, you could put a like circle in the cell to say a bridge connects to this cell, but we don't know in which direction.
Yes, agree. Let's see. Okay, so only one of these has a bridge. This has a bridge in some direction.
Oh, right. Is Emma has a good point. Those 2 in the corners, the 1-1 clues, they can't connect to one another because then they'd be isolated.
Yep.
Yes. Okay, right. So this, well, yeah.
It could go to one of the other islands, could move rightward and
snag it in the middle. Yeah, unfortunate, but yeah, I agree that they can't connect to each other because the whole bridge network is connected, which I did not expect to be relevant, but I suppose it is. So I guess one thing that does tell you is that this definitely doesn't connect horizontally, because if it connected horizontally, it would connect to the 1-1, and that would not work.
Right. So we could start to build a bridge going south from the 1-1 clue at the top.
Yep.
Yes. Okay. Yeah. So this one definitely goes at least that far.
Right.
And there must be an intervening island in that right column.
Right.
Yes. So there's island eventually. Similarly, this one can't go left either. Same reason. So this one we can also start building a bridge up, like that.
2 separate islands in that column, that form.
And so Emma has a good point that this cell can't be green because if it was, it would now force there to be no island over here to grab these things. So we have that.
So let's see, that 3 has to join the 5, doesn't it?
It seems very likely to me. The 3 tries to bend around here. It's certainly not going to grab the 1. So yeah, the 3 can't only connect by connecting around. So yeah, it's going to have to connect here eventually, and there's no way around it. I have to figure out how on earth am I going to articulate that. But I believe it.
Yeah, and there's no way that island is done with 3 because we can't have 5 bridges. So it's got to be
5
cells, 3 bridges.
Oh, maybe I was going to say it has to take this cell, but I don't think it does. Right. I think it could do that. Is still possible. Okay.
And the 1 has to join the 8.
One has to join the 8. Yeah, what else is the 1? Yeah, the 1 can't get anywhere else. So yeah, I agree the 1 is going to join the 8. So this island can't connect to this piece of bridge at all. because then that would be the end of it. So
Right.
that means that's blue, right? I think.
Unless both islands reach the... No.
They
no,
can't because
they
it's a
can't.
one island.
Right.
Yeah.
You'd have the same problem. Yep.
So actually both of these connect to this island because this can't be green either now, because if this was green, then it would connect to the one island and that would be a big problem.
So that
And,
bridge extends farther up.
Yep.
So for the two bridges to remain separate, then we need at least two more greens in the column. So that middle cell is green.
Yep. And all the other cells around the island are blue because one of those is green. We don't know which one yet. We agree with that, right?
Yep.
Yes.
And there's no 2x2s of blue, so that's that. Oh, there's no 2x2s of blue actually tells us which way it is.
Right.
There you go.
I saw a completely different 2x2 of blue. This blue isn't connected yet to the rest of the blue. Oh, this 2x2, or sorry, this 2 is done.
Mm-hmm.
Apparently there's a 2x2 of blue risk there. There's a 2x2 of blue risk there.
In fact, that
Egbert points out.
Never mind. That 8 region is almost forced. It has just one degree of freedom, because it could either be a 2x4 or it could take the cell to the left of the 8. But those are the options. So we need one more bridge coming out of the 5-3.
And it can't connect to the 8-1 island because then that would be a...
And it can't
that other one, Daniel points out, that other 1-1 in the top right has to go way left, because if it connected down, those would be an isolated group.
Yes. That is correct. So it has to go at least that far left.
Okay, so now we have some more restrictions.
That means that
there's no way this can connect down in either of these spots, I believe, because if this island connected down in either of these spots, it would connect to the 8 island.
Or the the 2-2 region is now a little restricted. It can't have any bridges going up or right.
I think this cell, the bridge can only go down, right? Actually,
go down.
Do you agree with that?
There has to be a bridge here.
Let me verify. I'm going to look at that, but doesn't this bridge just has to go down, right? There needs to be a bridge in this cell, and there's nowhere else it could go, right? So now this island is done. I don't know if we want to give it a different color now that it's done. I don't know. I think all the other colors look terrible. I'm just going to leave it here. I agree with Tristan. Oops, although not in Helper X mode. I have drawn this in.
How do I get this off? There we go.
Okay, so the other 2-2. Oh, right. We could have. Oh, no. It has to go left. The other 2-2 cell.
You can't draw borders in Penpa, Jim. Sorry, the other 2-2 what has to go left, right? Because it can't go down, right? Absolutely, yep. Because this one's done, right? Perfect. This is a really neat and natural way to make these rules work together. Yeah, I knew enough about Hashi to know that double bridges existed, but I did not read the rules closely enough to realize that we could absolutely do this in Sudoku Pad with no issues. Because normal Hashi puzzles, if you've done them, they feature that symbol.
Right.
You are not allowed to do. Let's see. Okay. I'm trying to decide if there's an interesting connectivity thing going on with this 8. I guess the point is this cell is always blue. Because if this cell's green, I just can't finish the 8. Do we agree?
Yes.
I was thinking through your two visions of what the 8 might look like, and realizing that in all of them that was blue.
Right, and then blue.
And so now this also has to be blue, I think, for the same reason. Because if this cell is green, then the 8 has to grow, and then the water's disconnected.
Right. So the blue between the 5 and the 10, it either goes down to expand or right. And that the other one would be the 8th cell. So we have a 4x4 green right there.
Yep. Agree. Oh yeah, I think this rule set was absolutely the right one, Nell.
Oh, Emma says the 2-1 island in the bottom row has to go left.
Yes, because it certainly can't connect to the 8 island. Oh yeah, and it can't connect right. It can only go left. Yep. Oops. That is not the right clue type. Oops.
I think you have to go.
Yes, there we go. Haha. I was trying to argue that this screen can't go up, but I think it can.
I'm wondering about which clues join which other clues. Like that 10, it presumably is there a way that I could join anything than the other than the 5 that's diagonal to it?
It feels unlikely, but I feel like conceivably it could join this 5 below it.
Yeah.
Like I don't think that's the likeliest outcome, but it seems vaguely possible. But I mean, if this 5 ends up joining that 5, that's going to be quite intense as well.
Right.
But if the 10 joins that 5 that you're hovering over now, where does the other 5 join to?
The 10? Wait, no, sorry. You're saying if this 10, okay, right. So you're arguing this 5 can only join the 10, really.
Yeah, what is that 5 joining to?
Yeah, it can't reach the 2.
So it could join the other 5. It either joins the other 5 or the 10, but the 10
those two can't join each other is the point.
Right. That's the point.
But if
however, if these two join, then there's no way this is connecting to anything.
Right. So then the 2 5s are connected and the island's just done.
Yeah.
Right. So we said, if this connects to one of those two, and we said it doesn't connect to that one, so it does connect to that one. Yep. And so we get a 5-5 island.
We get 3 bridges in the middle all going up.
Yep.
Yes, because they have no other way they can possibly go. Now, I was trying to say, I feel like one of these has to be water, but I'm trying to decide if there's a specific one, or maybe I'm wrong. But my intuition says I probably should be able to green one or blue one of those, but maybe I can't. Let's see. If this is blue, then this is green. I don't really immediately see anything out of that. I think we still haven't officially argued that the 10... Well, I guess now the 10 can't connect to the 2. Because if the 10 connected to the 2, it's definitely getting hit by more than 2 bridges. So I think now the 10 does have to connect to the 5, I think.
I'm wondering, let's see, could it... No. Yeah, I think that's the only possibility.
Yeah, the
Oh yeah, the 8-1 island, people are saying, I think it can only connect to the 5-3 island above it.
Yeah, because it can't connect. It needs to connect No, the 5-3 island is done.
Oh. So then it
can't
connects,
connect left here, so it can
so
only
it connects
connect
left
here.
there.
Yeah, so it connects like that, which means that this cell is green.
Oh, wait a second. We don't know if the bridge starts in that cell or the white one next to it, if that's the green one.
Yeah.
But we do know it ends there.
And so the cell below the 10 also has to be green, so that bridge can end there.
Which now means that's water, which now means that's green.
There we go.
And, there we go.
That is there. From the Carl says, wait, maybe it could connect from the left clue and up. There's not any islands up, are there? Yeah, we already know there's not any islands up, so it would run into that bridge, I think.
I think Carl might be missing the rule that bridges can't turn. It could connect up from the cell to the left of the 8 clue. Oh. Yeah, we have to back up.
Yeah. So
yeah, if this goes here, then that ends up going up. I see. Okay. Okay.
So the 10 clue, we just established it can't join the 2. It can't take the 4-1, obviously, it can't take the 7, it can't take the 6. So it's taking one of those 3 5s. And it can't take the row 3 column 6 5, because it would trap the other 5s. So could it take row 3 column row 3 column 4? Could that join the 10? And it seems like that would trap some water or something.
Yeah, I think that would trap. Yeah, it's tight, but yeah, that would trap some water between, because that would force this 5 to take that 5. And that would exactly entrap some water by making all of those green and some water in there. So yeah, I think these two definitely connect now.
Okay.
So the 2 has to connect to the 7.
Yeah. Right. Do I know that it has to connect directly to the 7?
Yes.
I think so, because I can't hide water behind it, because that water won't connect. So I know that at least happens.
And that island has to take one of the 2 cells in the second to last row that we don't have colored. At least one. Otherwise, we'll have a 2x2 of water. Yeah, down there. So in the second to last row
down there. Yeah, so you're saying those are green.
Not necessarily. Be careful, because this cell could be green instead.
I think that would trap water, though.
That would trap water.
That would trap water. Gotcha.
And in fact, yeah, so that has to be blue because I can't trap water.
Okay. Now the 5s in row 3 have to join one another, I believe. So there's no way that 3 can join one of the 5s. The 3 has to join the 6.
Yeah, okay, yeah. So
row 3 column 5 is green.
Yeah.
Whoops. I didn't mean to do that.
Oh, if you do like one of these, does that?
I have a. There we go. Okay, so this is still blue. That's still green. So this line continues yet again. And so this is, oh no, that doesn't still have to be blue. This could now be green and be part of that, and it would be okay. Now we do know there's a line coming down from here, a line coming down from here, and a line coming down from here at the very least. So all of these have to be blue because of the line, right? Because you can't have them starting from anywhere else, and this is a 5-5 island.
I think the leftmost one, not necessarily.
Oh, the left one doesn't have to go down. But these two do have to go down, right? Yeah, because they can't go up and they can't go left or right. So at the very least, these two are water.
Yeah.
But yes, I agree. I got over enthusiastic.
So I think it is true that the 10 island can't get as far left as column 4, which really constricts it.
I definitely agree, by the way, with the chat. That needs to be green, because if it's not, there's going to be a connectivity issue. The 10 island can't get to column 4, you say?
Yeah, so it can go 1 column left, but it can't go 2 columns left, because then all 3 of those bridges from the 5-5 island connect to it.
And we also know that the cell above the 10 has to be green, otherwise it would trap water in trying to connect the 10 and the 5.
That is true. So is it these 8 cells plus that, or are you claiming those are the only cells the 10 island can possibly take?
Yeah, because
I think that's what Tristan's claiming. I'm not convinced about this can't make it to row 4 or column 4 business. But if you claim
something else
can't make it to column 4, then it's forced.
Yeah, because something else would have to go under it, and there's nothing else that can go under it.
Why would something else have to go under it?
Because then you'd have 3 bridges connecting the 5-5 island with the 10 island, which you can't have.
Each pair of islands has either 0, 1, or 2 islands or bridges connecting it. That there is a rule that I have forgotten because it has not been relevant until now. So yes, I do agree. Yeah, if green comes over to column 4, there's no way I can interrupt this with an island in either of those spots. So I think that does mean that this island just looks like that, right? I don't think there's any other cells it can plausibly take.
Yes, that's
okay.
And so this is green.
And now we do get that bridge there.
Yep.
Yeah.
And now this island has its 5 bridges, so we don't get to draw any more bridges through this island. That bridge keeps going up at least to there.
Yeah.
We don't yet know the direction of this bridge.
Let's see, the 4-1 has to go down. Because the 5 is going to take left, the 5 region is going to go left or down.
Well, I mean, if you just look by geometry, the 4-1 can only
we'll
take...
do the no 2x2 of water, and that will do it for us without too much difficulty. Oh, I guess this could still be green.
No, yeah. Yes. 2, 3, 4, 5.
So
yeah.
So my point though was that above the 4-1 clue, that has to be blue because of how the 5 region's going to expand.
Yes. Okay.
Yes.
Yeah. Yep. Very nice. Yep. Okay. So this definitely grows down. It's definitely not the same as that, so it grows down, and so then it finishes. Okay, so
And now 7 goes up at least once.
Yep.
Yes. Yeah, we need 2 more bridges on this 6 thing. I agree with that. Let's see. This blue water. No, sorry, no. This water is connected. I'm right.
I was about to say something, but then it was very obvious. 2 column 1 is water, says Emma.
Oh, because then the bridge in row 2 would go all the way left, and then we can get more bridges coming out of that. 6 island.
Yeah, yep. Agree. Neither of these 2 cells have a bridge leaving them, and that cell. So that's 2 of the 3 cells that don't have a bridge leaving them.
Right. The row 2 bridge is going to take the 6th cell, and then row 1 column 1 or row 1 column 2 is going to be the 3rd bridge going downward.
Correct.
Row 3 column 2 is not going to reach any of the islands, so that's blue.
That is true.
I think the interesting thing now is how the upper 5-5 island is going to get its 5th bridge.
Yeah.
I don't think this island can connect to the 4-1. I think if it connects to the 4-1, we've disconnected our bridge network, haven't we?
Have we?
Because how am I possibly connecting it then? Because this 5 can't connect up, can't connect. Oh, maybe it could connect left to the 7-2, but it's still not going to connect to the stuff above it, right?
Ooh.
Carl says row 3 column 4 having a bridge going left breaks the 6-3 in row 1.
Yes. Yes, it does.
So it only has a bridge going down.
So, whoops.
It's not the right tool.
And now we know that cell is blue, and it finishes there.
That cell is green.
Green.
That cell is blue. Blue. I'm doing very well with my colors. So that cell is green. So that cell is blue. And that cell is blue. And that cell is green. And now our islands are done.
Nice.
This now can only go down. It has no other choices. This can only go left, therefore. This finishes like that, and now this can only go down.
And that should be it.
And I think we're done. Very nice.
That was really cool. I liked that.
Yeah.
I've always wanted to see Hashi hybrids, but the two bridges thing always threw me off of figuring out how to incorporate other things. I think this was a really good way to combine those, though.
Yeah, I really like this this way of combining them.
Nice job, Nell.
Absolutely.
All right.
Alrighty, are we going to take a quick break before our next puzzle?
We are, because I need to reset up my scene for Sudoku pad.
I see. All right. Well, we'll be back shortly, everyone, with another puzzle of some sort of madness.
We will be back in a minute. Bye for now. Welcome back. Let's see. I think
Welcome back, indeed.
I think I have reasonably set up the puzzle over here. Looks pretty good. Okay.
One of those number puzzles. All right, so we've got normal Sudoku rules. We need to shade some cells so that unshaded cells form a single orthogonally connected area. And each connected shaded region touches the grid boundary. So that is standard cave rules, I believe. A circle is always unshaded. Let's do that. And the digit in the circle equals the number of unshaded cells visible in a straight line from that cell, including the cell itself. Shaded cells obstruct view. Each shaded region contains a corner clue, which equals the sum of the digits in the region. Digits may not repeat within the shaded region, and the digit in the clued cell is always the size of the region. So we can make all of those be shaded. And we can do things like this 9 clue has to be 2 or 3, because it's going to be either a 2 or 3 cell sum. And the 11 clue also has to be 2 or 3, because it can't be 4, because you can't make a 4 cell sum to 11.
So we get some interesting X sums logic in this puzzle.
So yeah, we get our fun little X sum stuff. So and this can't be 2 because 2 and 11 is not plausible. So this is at least 3 and at most 4, just for the record.
Oh, 37 is a fun one because it can't be 8. Because it would
be same reason. And this I was noticing has to be green because if it was gray, it would break the 9 cage. But yeah, so it can't be 8 because that would be missing 8. So does it just have to be 7? Because let's see, the outies sum to
be 6.
Okay, could be 6 or 7. Okay, yeah, 6 or 7. Yep. Okay, so this number is a minimum of 4, I suppose. For whatever that is worth. I suspect not incredibly much. This is at least 4 and at most 6, just to write in the possibilities. And this is at least 4 and at most 6, I think, as well. These are each strictly larger than 2. Oh, no, sorry. One of them could be 2. Sorry. One of them is strictly larger than 2. A very powerful deduction, I'm sure. Let's see. This green eventually has to get out some which way. Oh, right. Nell is reminding us that there are rules to the puzzle. And one of those rules is that the cages in gray have to reach the edge. So it certainly can't be 4. I don't even know that it can be 5, can it?
How can it be 1? How it can't be 5?
Yeah, no.
I think this just is a 6.
Ooh, so
get to bring out our dancing animals. Wop 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 wop. Boop boop boop. Wop 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 wop.
I don't have a penguin, so I brought a possum instead. This is persimmon.
Pea animals.
The 60 dance is a PG booty shake.
Okay, so yeah, so this is going to create like a weird cutoff in whatever. It's not going to go there, I can tell you that much. In fact, actually, is it true that this cell has to be green, actually? Because I think it's going to take all 6 cells for it to get to the border, and it can't go this way and get to the border, right?
Agree.
Because it's going to run into one of those cages. Let's see. Yeah, so if it goes up, then it's going to do, I want to say that, which is going to force this digit to be exactly a 4. because of the 2-3 pair and what that would do to the green. I am clocking. I don't know, that might break, but I don't immediately see that it breaks. And yeah, these have more variation, I think. Oh, right. Sorry, Martin is correct. That breaks because it sees the entire 21 cage, which is 6, 5, 4, 3, 2, 1.
Nice.
So actually, that cell is also green, because if this cell were gray, it would have to do that. Great spotting, Martin. So that's also
sick
green.
point to Martin.
So either that's all gray or that's all gray.
So
But it
I
is
wonder if we could
ordered.
extend that further on those other circles in row 5. Because what could that circle be in that case?
So whatever circle it touches
okay,
has
so
to be large.
Yeah.
I think, yeah. So I think here it's true, but Nell is pointing out it could do something like that is fine if it's going left or right. So in fact, it might have to be exactly that because of the way that this has to bend. Because if I just do that, of course, I'm still breaking this circle.
That's right.
So
does that mean the cells on either side of the 6 are green?
Let's see. That's still not enough. But that would make it a 7, which is okay, I think.
But I think the 6 can't go right now because of. Oh no, it could go right and down. No, it can't.
Yeah, there's a cage in the way. Yeah, the 6 going right. I don't think there's any way this cage goes right. Yeah, I think it's going to do exactly the same thing to the circle.
Yeah.
Wow, that's very cool.
So yeah, so the 6 is going to have to eventually go left.
So that cell to the right of it is
going to be green. Yep.
And now we have a no, what's it called?
Oh no, yeah, no. Battenbergs, yeah, no checkerboards.
And now
we
know.
So the point is,
mind.
if I make this gray, then I need to connect the green to the green, and there's no way to do that without severing one of the grays from reaching the border. So that actually has to connect through there. And I agree with Carl, it always ends there. And so those are both green as well.
And it's got to keep going out of the box, right?
Right. We said it can't take that cell either, so it's got to keep going, and it can't take that cell either, so it's got to keep going like that. And again, those are both going to be green, like that. And these are all from 1, 2, 3, 4, 5.
Mm-hmm.
And this is going to be 7 or 8, right? Yeah, this is 7 or 8.
No, because it could be whatever 4, 4 is, for example.
Yep.
Oh, right. Sorry, yep, you're right.
Or 4, 5.
Okay, well,
if
this
that's
37
gray.
cage now has to come out here because it's got to be huge, and it doesn't have that many cells it can get without going there. So those are going to be in the 37 cage.
Oh, now 1, 5 is pretty limited to what.
Yeah, how it's going to connect to the rest of green.
Yes, because yeah, right. As soon as that became gray, yeah, this now has to be at least 4, but it can't be more than 5 because it can't be 6 by sudoku. So this is only 4 or 5. And given that this cell's always green, so we get that at least.
Oops. Hopefully that didn't screw up.
Oh, so this cell sees the entire 21 cage. So this is a 7, 8, or
9.
What exactly breaks if this is a 3, Ambrose?
Then the gray has to continue more to avoid a checkerboard.
Oh, right. The checkerboard thing. Right. So this cell just can't be gray because of the checkerboard thing. Right. Okay. So this cell is green by checkerboard logic, because if this was gray, this would be forced to be green to keep the cages apart. Got it. Okay. So this is green and that's gray. Okay. Which makes that a 2 and that a 7 and that a 6 and that a 3. So we get some action. Still be green as long as that is gray, I suppose. This is gray. That makes that green, I suppose.
I think in all possible universes, row 1,
these are
column
both
6
green,
is
right?
green.
These are definitely green. Can't this be a 4 and that be gray?
Ah, shoot.
Or is that breaking the 37 cage or something? Oh, and this definitely... Oh, no, sorry. This does not have to go down because of the previous point. Row 2, column 5 can't go down for because it would create the same checkerboard pattern if it went down, Martin points out, where this would be forced to be a checkerboard, and I'm not allowed those. So that's definitely gray. And so that's green by the same checkerboard logic, because again, if that were gray, I would get a checkerboard on these two. So we've got at least that much of the 6 cell 37 cage.
Oh, huh. Ron has a much simpler point that row 6, column 1 simply can't reach a cage.
Oh,
that's
yeah.
true. And row 7, column 1 can't either. Nor row 6, column 2, I believe. That is a classic reachability argument. Okay, so now...
It's 5, 8, or 9.
I guess this could be 5. Yeah, it could be 5, 8, or 9.
Could it be 8 or 9, actually? 1, 2, 3, 4, 5, 6, 7. Oh, okay. It can't be 9, but it could be 5.
9 is too big, but it can be 8. Yeah,
5, 4 is gray, then 5, 1 is broken, says Eckbert. Oh, true. Because, well, let's see.
it would be 5, and that would be 5. Let's see, I think Emma notes that this cell's always green. I think this... No, that cell's not always green. Sorry, that cell could be part of the 6 cage. Yeah, that might be the only unreachable cell in column 9.
Oh, Martin says 1, 7 can't be gray, I think.
Yeah, same point. If that were gray, we'd get our checkerboard pattern. So that's green, which makes that gray.
Oh, the digits for 2, 8 is pretty limited. It's got to be 1 or 2, right?
2, 8. Yeah, so so what's left is a 2 cell sum to 8, and so it can't be 3, 5. And so yeah, so it's either going to be 2, 6 or 1, 7.
Row 1, column 5 can't be 5 anymore, because the 37 cage has to connect to the edge at the top. Because it can't get past the 11 cage.
Right. So yeah, it's gotta...
Oh, no, wait, it could... What? No, not in 6.
Right. This cage, right, sorry. I said before this cell didn't have to be green because it could be part of the 37 cage, but it absolutely can't, because that would be a 37 cage that didn't connect to the edge.
Right, right.
To
row-
that point, yes, one of these two has to be gray for sure.
Making row 1,
and
column 5,
not
4.
both of them. So this cell's definitely gray. And yes, and whichever of these is gray is definitely making that a 4. I agree.
Now we have some checkerboards to avoid in row 4.
And so that means the digits in this 37 cage, because this cell sees the whole 37 cage, and it's therefore a 1, I believe, because the digits missing from the 37 cage must be 1, 3, 4, because they sum to 8.
It could be a 6.
Oh, it could be a 6. Okay, so this is a 1 or a 6 only.
Math Pesto was just pointing out that row 4, column 7 has to be green by checkerboard.
Yes.
And
agree. And what? Sorry?
Row 4, column 5 also.
Row 4, column 5.
Oh.
Yep.
So now we know how that cage finishes.
This. Yep, and so
might as well pencil that.
Yep, I was already definitely going to do that. So we do know that these numbers are not 1, 3, and 4. So they are 2, 5. We've already got the 6, 7, 8, 9 is what these digits are, I believe. Right, we agree. It's 1, 3, 4 that's missing from this 37 cage, no matter how it is arranged.
Circle now 5.
Yes,
Yeah,
circle's now 5. Yep, so now that's gray, and it's got to find a clue, so it ends up joining that gray, which makes that a 4, makes those double green. This now certainly isn't any... Oh, maybe it could technically be that. That is green. I agree with the marker. Hey, Jay, how are you doing?
Oh, nice.
Okay, let's see. These are not 5. That's not 4. That's not 5. Okay. Oh, I should mark this cell 7, 8, 9 for sure. Oh, this cell is all right. This cell's 5 because there's nowhere else for the thing. Yep. Yes, this has got to be green because it can't be a checkerboard. Agree with that. Okay, this cell is now a minimum of 6. So it is a 7, 8, 9 as well, which actually gives us a bizarre 7, 8, 9 triple in this box. So these are 1, 2, 3, 4.
Let's see. Laura says, where's 3 in row 2?
3 in row 2. Yes. 3 in row 2 is there. Good. Yes, this needs to avoid a checkerboard. Let's see. This number is at least 6 again. So this is 6, 7, 8, or 9. Do we know what these numbers are? I'm terrible at doing this.
It could be 1, 2, 6 or 1, 3, 5.
I see.
Yeah.
Okay, well, I know the 6 is down here, so I know the 6 is up here, but I don't know if that's very exciting in the grand scheme of things.
See, Jim says the 7 in the 37 cage looks down because it's got to be in row 6, column 6.
Yes, that is very true. Very wise, yes. Yeah, this gray cage can't get all the way over here is Eckert's point, because if it does, then it can't also make it to the edge. So that cell's always green.
Same for the... oh, wait, no, never mind. The 13 cage says 9, 2 is either a 2 or 5. Right, it can't be a 6 with a 1, 2, because... Okay. Yeah.
Okay.
Yeah.
Okay, this digit, yeah, I guess I don't quite know what that digit is. I don't quite know that this can't be gray, unfortunately. Actually, maybe I know that this can't be green. Is it possible it breaks if that's green because I'd make too many of these too big? I don't think it quite does. Actually, no, maybe. So what can this really be? So if this is as big as 5, or sorry, if this is bigger than 5, then it's at least 8. And that certainly breaks because that would make all of these at least 8. And all 3 of them can't be at least 8. So this is, in fact, at most 5. So this is minimum 2, and it's not 3, so it's 2, 4, or 5. 2, yeah, 2 is technically possible, I think.
It can't be 4. Wait, never mind.
Oh, Beltita mentions that 7, 6, row 7, column 6 has to be green because of the 8, 9 circle clue.
Yeah, so there's at most 1, 2, 3, 4, 5, 6, 7, right? So yeah, so that cell's definitely green. Good. We don't have anything like all circles are given or anything crazy like that, right? Okay, so yeah, so let's see. Can I do any more the other way? 1, 2, 3, 4, 5, 6, 7, 8. No, I can't. Tragically.
Yeah, nothing can get there.
Yeah, now yeah, if that's gray, now my 6-cell cage doesn't make it to the edge anymore.
6. Now the 6, 4 clue is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's just done, right? Or did
I'm going to point out Carl's point real quick, and then I'll get to that. If either of these cells is gray, then these are both gray to connect, and it makes both these circles the same. So those aren't gray.
Nice.
So, yeah, row 6, column 4 is row 6, column 4 already sees 9.
Excellent. That is helpful. So that sees 8, and that is a 7, and that is gray. Let's see. If this were green, this would see 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this would if this is green, then that's green. If this isn't green, then this could still be a 3.
Row 9, column 5 is 8 or 9 at this point.
Just by the fact that it can't be 4. Can it be 5?
Well, it's at least
sorry. It's already at least
it's already
6.
seeing
Okay.
6, so it's 8 or 9.
So yeah, so it's 8 or 9, and so that's 1, 2, 3, 4, 5, 6, 7, 8. Those are both forced to be green.
Now the 24 cage has to be careful about.
Now this can't possibly be green, because if this is green, it makes this a non-sudoku number. It makes it at least 10. So those numbers are gray.
Oh, now we know the 24 clue is 6 cells long. In order to get
because it still needs to get to the edge. Yeah, so that is 6.
So anywhere that doesn't directly put it towards the edge, because now it has to flee to the edge. So
this number is exactly 3 less than that. So that means it is a 5 or a 6. Because these two see the same horizontal cells, but this sees 3 extra vertically.
So the 24 cage can't take row 5, column 7. It can't take row 7, column 8. Yeah, Math Pesto is saying the same thing.
Yeah, because if it took either of those, it would never make it to the edge.
Yep. So it has to go straight to the edge, and it can't take row 9, column 9.
Take that cell anymore, right? Or so nothing can take any of those cells anymore, right?
Or row 9, column 9.
Which hopefully makes this 8 correct. Oh no, it does. It does make the 8 correct. Good. Since we filled an 8 in there and didn't ever actually check.
Row 9, column 9 is green, which resolves a lot of circles.
Yes, this is green because this can't get to it anymore. So now this is a 9 and a 6. Let's see. Those aren't 9 anymore. Those aren't 8 anymore.
So 2 9 sees 4 cells. It could possibly see 1 more, but row 6 column 9 can't be green, otherwise it would see 2 more.
Yep, so that
Yep.
finishes the 24 cage.
Yep.
Yeah.
Okay. So that just tells us that this is just a fillable
4.
digit of a 4, which makes that a 5, which makes that green, which makes that gray. And it's a 6 or a 7, if I recall how the math worked out.
And that last circle fills in.
Okay, those are a 2-8 pair now, so that seems to
It's
make
an
that a 9. And so that makes that a 1 and a 7.
That's a 5.
That's an 8.
This is the digit you're telling me is an 8. I will fill in an 8 for you. This digit is also a something. It seems to be a 7. Oh, that 2-8 pair has made that a 5. And the last digit I'm looking for this cage is what? 7. Okay, so so the 7 is there now. So that is 7, and that is green.
Woohoo!
So this is something. 4? We're gonna say 4. Let's see. Okay, and boy, do I not know my 6 cell 24 cages.
The Audi is 21. I feel like that could be a few things still.
Yeah, probably. We'll probably need to Sudoku some digit into it or something. Well, the 7 isn't in it. I can at least say that. Oh, actually, okay. So the 7 in this box, I can just Sudoku out of those cells. So one of those 2 is a 7, which means one of these 3 is a 7, except it's not those 2. So there's a 7 placed there. These are 1, 6, and something. 1, 6, and 3.
The options for the 13 cage are limited because it could be a 1, 3, 5 or a 1, 2, 6. And both of those options are quite constrained.
In fact, actually 6 is placed here by Sudoku.
Oh, perfect. Okay.
So that makes that a 2 and a 1. 2. Let's see. So these are what? These are 3, 8, 5, 9. Okay.
Oh, row 5, column 2 and 3, they see the 21 cage plus the 5. So they're 7, 8, 9.
Yes, very good. And they also see an 8, so there's 7, 9, and so that's the 9, and that's the 7. Very good. Okay. So these are 1, 2, 3, 4 just by the row. And that one can't be 1 or 3, and that one can't be 4.
6 in box 4, says Ron.
Yes, 6 in box 4 is there. Let's see, 6 in box 6 is 6 in box 3 is in one of these 2 places, and therefore 6 in box 6 is I think placed.
Yep.
Oops,
row 4, column 8.
Yeah. I was highlighting and then it got out of hand. As it so often does. Right, and it sort of finishes up the 6s with those. Let's see. Oh, there is a 7 in this cage by Sudoku. So we've got a 6 and a 7 for what it's worth. Isabella says that tells us what it is.
1, 2, 3, 5, 6, 7.
7. Yeah, so it's a 6. Got a 6 and a 7, and then 4 digits that add to 11,
which is 1, 2, 3, 5.
1, 2, 3, 6. Sorry, 1, 2, 3, 5, right, and 7. And these aren't 7. These aren't. Sorry, that one's not 1, 3, or 7. This one's not 5. That one's not 5. Okay.
Pencil 8 in box 3, says Ron.
So 8 in box 3. Yes, 8 in box 3 is in one of these there places. Let's see. Is there anything spicy going on in this row? Not immediately.
Well, row 9, column 7 isn't an 8, at least.
That's true. I concur.
Let's see. Emma says 4 in box 6.
Yes, because we have 2 4s looking in, so that has made that a 4.
That's going to put the 4 in box 5.
It does. And now one of those two is a 4, although I don't necessarily need to pencil mark that.
Let's see.
4 is placed in box 8 by Sudoku.
I was noticing that this digit, if it's a 2, it needs to go there in this box, but I don't think that quite breaks. If it's a 5, then it needs to go there. But neither of this break. What in what box? What, Tristan?
The cell you have selected is a 4 by Sudoku.
Yes.
Handy. Let's see. This has got to be the last 1, 2, 3, I suppose, for the column.
Oh, 1 in row 7 has to be in box 8.
Yes. So that is not a 1. This means one of those 3 is a 1. Let's see. Is any of this spicy if we fill it in? Not quite. One of these two is a 1, 2, 3.
Oh, people are noticing like some cells that are going to have
Yeah,
digits.
that can't be 1 because it sees all 3 spots that could be 1 in the 24 cage, and that can't be 1 for the same reason.
Right, and now row 6, column 5 can't be 1. Because it's going to be the same as 5, 7.
It's going to be the same as
or just where's the 1 in row 5?
Yeah. The 1 in row 5. I got it. Yeah. Sorry, you saw this as 2 overlapping triples. Got it.
Suggesting catch-up time.
We can catch up if we need to catch up. Yeah, that I'm not quite sure if it's necessary yet, but I'm not opposed if need be. Okay, that was a little too messy even by my standards. Let's see. Do I know anything about these cells? Yeah, I am going to record my note that that one can't be 1 just for the sake of it. Oh, I guess interestingly, 9 in this column, I don't know if it's interesting, but 9 in this column is definitely in one of those 2 cells. Maybe it's not at all interesting. It's possible. Let's see. I know one of these 2 is an 8. And the other is a 1, 2, 3 for what it's worth.
So
so I guess this is only a 3 or an 8, but I don't think that does anything.
I think the ketchup suggestion might be helpful because all of these are the same.
Okay, let's see. So I see why these 2 are the same. Now this one has to show up in the 21 cage, so it's there. Got it.
relishing row 5, column 4, and 7, 6.
Row 5, column 4, and 7, 6.
Yep.
Right. Because yeah, this is the other member of this triple by the column. Agree.
So relish has to show up in the 21 cage or the 24 cage. Yeah, Martin is
and the
seeing
21
this.
cage.
Oh, the 24 cage.
So this is
Sorry.
definitely over here. Oh, sorry, it is in this cage. Sorry, this is definitely over here. And
No,
so
oh yeah. Okay.
So the point is, it's therefore not in any of these cells, and it's not 6. So therefore, that's relish. I believe. So this cell is not 5 anymore. So the 5 is actually in this row, although we actually already would have known that if we would have thought about 5 at all.
But now relish is placed in row 4.
And
yes,
relish,
that cell is a relish.
Relish can't be 3 because it's in the bottom row of box 7.
The bottom row of
Yes.
box 7.
Relish is only 1 or 2.
Yes, agree. People are saying they're saying that relish by sudoku is one of these 3 digits, and so it is not any of those things.
We now have a 1, 2, 3, 4 quad in row 4.
Yep, placing the 9 by Ron.
Nice.
So this must be the red. Oh no, not necessarily. Sorry, this is we just know this isn't the green 1, 2, 3.
Oh, in
yes,
bottom...
box 3. Relish is 1 or 3,
nice.
And so therefore relish is not 2. So relish therefore is 1. Good eye. So that has made that 4, 3, 2.
That's going to do a lot of work.
6, 3, 1. It's made that an 8 and a 5. It's made that a 2 and an 8. Seems to have made that a 6 and a 2. Seems to have made that an 8 and a 1. And an 8 and a 9 and a 4. 9, 5. Let's see. Oh, red circle is now 3. So we can get rid of our circlage.
Yeah,
there
there's
we go.
more
Okay,
spinning.
so that is a 2. That is an 8 and a 3. That is a 7 and a 3. That's a 7 and a 5. That's an 8. And if we hit the mark button, Mark will tell us where the 9, the 8, the 2, the 5, the 2, the 2, the 9, the 5, and the 1 are. Very nice.
Okay.
I quite enjoyed that.
That was great.
Yeah, that was really smooth. I really liked the trying to figure out, given the length of the cage, how it's going to reach the edge of the grid. That was really nice.
The geometry of this 21 cage was really cool.
Yeah. Very nice, Jay Dyer.
Indeed. I am going to quickly stretch, and then we will continue the madness of the puzzles in a minute.
Yep. We will be right back with another puzzle.
All right. See you all shortly. Welcome back, everyone.
Back.
Next up, we have Mafia by Agents. This is a chaos construction puzzle. So that means we need to put 1 through 9 in every row, column, and region, but the regions are for us to decide. So each cage must be contained entirely in one region, and cages within the same region must have the same sum, and cages in different regions must have different sums. So I see a couple lines immediately. So these two 5s can't join because that would be too big, but the 5 and the 4 also can't join because then the sum of the numbers 1 through 9 would be even, and it isn't.
Right.
And so I think that actually forces this whole thing, because now I think that just is a region.
Now we know they're each.
Yep. And so they're each 15. And so I can't ever use 15 again. And these are 6, 7, 8, 9. And these are 1, 2, 3, 4, 5. Oops. This is interesting. This 5 can't join the 4. It would isolate this cell. So there's a border between those.
Nice.
And every region is going to need to have a cell now that is not in a cage. Because if there's no cell in it that's not in a cage, the repeated sum has to divide 45, and we've used 15, and I don't think I can make 9 separate sums to 3 without some serious jiggery-pokery. So we have that. Let's see. So this in particular can't connect to both of these, making that a region. That would be bad. Let's see. Oh, 5 sums to 9, except there are no 1-cell cages. Right. And so 5 sums to 9 would require a 1-cell cage, and there aren't any. So let's see. So this 5. Oh, okay. I guess I'm saying this 5 also can't join this 4 for that same reason that we noted before. So we have that problem.
Oh yeah, so
yeah, right. Sorry, were you going to say the same thing about this line? Yeah, chat was just telling me if these two connected, it would force this to be in there by contiguity or whatever you want to call it. Contiguousness. I am looking at this and feeling like this needs to take that cell, but my argument about it is pretty ugly, I think.
Well,
I'm not sure it can actually.
It needs to take 3 more cells after if it were to take the 4 cage and the 2 cage. So how could it take 3 more cells?
Couldn't it take both 2-cell cages?
It could do that.
But I think if it doesn't take this cell, what cell can it get that's not in a cage? And I think the answer is there isn't one. And it needs to have a cell that's not in a cage. So I think this now Emma has a much easier argument, which is that this definitely takes that domino, because if it doesn't, it's forced to be the thing that it's not allowed to do. So Emma says it's immediate that these things happen, and now we can just sort of do the things that we've already noted, which is that now it's going to have to take this, and now it's 1 cell short, provided I can count, and so it's going to take that. So Emma actually gave us an easier argument than mine that this was going to be the case.
Now we have a modularity argument for the possibilities in row 1, column 3.
Yes, because the totals of these are all the same, and so that means that the sum of these is divisible by 3. So this also has to be divisible by 3, and it's not 0. So this needs to be 3, 6, or 9. Okay.
And Emma says the 5-cell cage has to take the domino below it. Yeah.
Yep.
Yes, because it doesn't have anywhere else to grow. So yeah, these are all part of one. And I was just noticing this has to take this 3-cell cage, because if this tries not to take the 3-cell cage, then it can't take this 3-cell cage either. And then it ends up taking this, and now this region ends up with 40 gajillion cells. So these two are the same region as well.
We could put a border on the right of the domino.
The
red
yes, it definitely does not take that cell. I agree with that. And it doesn't take, and on the left as well, it doesn't take that either. So we've got all of that. Todd points out now this sum is 16 or greater. So in fact, it's 16 or 17 are the only options. So this is from 7, 8, 9, and definitely has a 9.
Very nice.
Okay, if green doesn't take this, then green is at 5, 6, 7, 8, 9, 10. So green also takes this. And now green certainly can't take that cell, or it isolates a cell. So green's last cell has to come from there. Okay, let's see. We can do... Oops, I didn't mean to make that white. So this is another region, which I think probably joins this 5, but I don't know that it has to. That's true. This is also a 3, 6, or 9 because of the same reason, and it's a different 3, 6, 9 than that 3, 6, 9. Am I going to get to color 3, 6, 9s? It could be spicy. Let's see. If this orange doesn't take that, then it definitely takes that, which would be 6. And then it could take that, which would be 9.
I've got another thing, I think.
Yeah.
So if row 1, column 3 is a 9, then this, oh no, sorry. If it's a 6, then the sum is 15 for the cages, right?
Let's see. If it's a 6, then the sum is 13 for the cages, right?
13, sorry, 13. So let's see, would that work with the 7, 8, 4, 9? Okay, never mind. That is actually fine.
Josh points out that the row 5, column 1 cage takes the cage below it.
That is very true.
And it can't take the domino cage in
right,
column,
because that would create a second 15 cage. So it needs 2 more, but those 2 more aren't in cages. I mean, this is dumb, but this 3-cell cage can't join that cage because it would break orange. So I will make the most minimal pencil mark ever. Let's see.
If orange doesn't take the 5 cage, what would it do?
It would end up taking exactly these.
Exactly that. Is that a bad?
Orange says the 5 cell, or sorry, Ron says the 5-cell can't be, or 5 cage can't be orange, but I don't see why.
What's interesting is 4, 9 is always a 3, 6, 9. Because it's exactly the one missing.
But if orange looks like this, then the one missing isn't a 3, 6, 9 because
the
total isn't multiple of 3. Yeah, no, Ron, this cell isn't in a cage. If this were orange, this is a 3-cell cage and a 5-cell cage. This is either red or it's in the 5-cell cage for what it's worth. Yes, I also noticed that, afraid not, but I attempted not to, and I attempted to restrain myself and not type it in the cell. But
yeah, let's see.
I mean, we do know that the numbers in this aren't very large, I suppose, is a
yeah, I mean, there are a
worthwhile
few
thing.
digits that have to be in it, but I don't know if that's very helpful.
Yeah, and the Audis in this, or the Audi in this is either, let's see, what are the two options? So the total, if it's 16, the Audi is,
Audi's.
why am I getting the Audi is 13? 30 can't be the Audi, right? Oh, sorry, there's two more cells. Sorry, there's two more cells. I see. Okay. I somehow convinced myself that 5 + 2 was 8, so I only had one more cell, and then I was doing the math and convincing myself that one cell had to add to 13 or 11, and I was having problems.
Let's see. Josh says row 6, 8 can't join row 6, column
9. Yes, agree. Same reason it would force that orange couldn't finish. So agree there. And now I agree with the assessment that these two are always in the same region. It's just a question of whether that region is orange or not.
Right.
Yeah, I think that looks feasible to me at least. Center line stitching, yeah, these are stitched together. Always popular. I'll just like do that to indicate that these are all the same. So this would, if these are orange, that would be the last 3, 6, 9.
Right.
Is there any way that it's possibly possible that it's a contradiction that that cell couldn't be 3, 6, or 9? I don't think there's any way, but who knows? Because it would be one of each 3, 6, 9 in those cells, if that's true. But yeah, I do not immediately see anything with that.
So this might be not helpful, but in the yellow region, the sum is either 12, 13, or 14. The 1 and 2 has to go in the 4-cell cage somewhere.
That's true. And we know that there's a 1 and a 2 in here, at least. Probably we also know there's a 3 if we really think about it.
4, 5, 6 is 18, so yeah, it needs a 3 as well.
Yeah, so maybe if we do our due diligence and hunt down places we know there's 1s, 2s, and 3s, we can make some elaborate Zackwing or something.
Let's see.
Do we know that every region has at least 2 cages? I don't think we know that, do we?
No.
I was gonna say, like, if we knew that, we'd know the sum of this was at most 17. But I don't think we know that.
I guess it might be worth asking, how could that get 4 non-cage cells? Can it do that without blocking red?
Let's see. It could take like those, and then red could take, say, like those or something.
Okay. Oh, well, yeah, we know. Let's see. There can't be. So what possible sums do we have accounted for? We definitely have the 15 in the orange region. From yellow and green can be from what, 12, 13, or 14. Red could be 16 or 17. So I feel like that would put a lot of pressure on that remaining 5-cell cage if it joined up with something else, but probably not enough pressure at this point.
It would have to be the other of 16 and 17. I guess that's only if it joins up with a 2-cell cage. If it joins up with a 3-cell cage, then there's
Right.
I guess annoyingly many options. Uh, let's see. Yeah, this is going to grab 2 more cells, and it's got a lot of flexibility on what it could be. I feel like this would not be a 4-star puzzle if we were supposed to like do some weird min-max argument on the total number of cages and the total number of sums and the total number of empty cells or something like that. Although it sort of worries me that we maybe should try and think about it, but I don't really want to think that globally about this. Uh, uh,
I've got something. It's a little bit look ahead, but if row 1, column 3 is a 9, then we know that the yellow region cage sum is 12, but the orange next to it has to be a 7, 8.
8.
So the
So
row 1 domino can't
would
sum
have
to
no
12.
value.
7,
Right.
8, 9.
Okay. So this is never a 9.
Yeah.
Okay, I agree. Uh, uh, let's see. And Eckbert does it the other way and says if this is 6, 9, it makes this 3, but there's no sum to 14 that works.
Ah, I like that.
So this can't be 6, 9 either. So it is 7, 8. And so 6 here corresponds to 13 over here. So it would be 4, 9. And if that's
right.
a 3, these will sum to 14 and they'll be 5, 9. Right. So is there always a 9 in this domino? Did I do that right?
Yep.
AFK points out that you can take 7, 8 out of the other orange domino.
Ah, yes.
Yep.
Oops. I think that means there's always an 8 down here. Is that correct? I certainly can't put the 8 with a 9. I guess no, it could be 1, 2, 3, 8.
That'd be 14, yeah.
Yeah. No, sorry, 1, 2, 3, 8 would put 2 3s in the yellow, because if this were 1, 2, 3, 8, that would be 3 as well.
Yep.
So I think the 8 has to go down here. So row 1, column 9 is pointed out, therefore is not enormous, at least. It's not 7, 8, or 9.
So it's like 3, yeah, it's 3, 4, 5, or 6. That's not great.
Can the total of this, you're right, the total of this can be 12 if that's a 9. Oh, so this can't be 3.
Yep.
I guess, because if this were 3, both of these digits would be 9.
Would be 9.
Right.
Which feels insane, but what are you going to do?
Emma says yellow 7 is row 2 in the 4 cell. Yeah.
Right,
Yep.
right. That is okay. That's very good. So yeah, the total here can't be 16. So yeah, so there's a 7 there, because the total can't be 15 either.
And then the 7 in green has to be in that bottom cage.
Yep. So now keep in mind, what are the 2 options for the total here? It could be 12 or 13.
Yeah.
So 1, 2, 3, 7 is the absolute minimum that this can be, and that's 13, right? So I think this has to be 1, 2, 3, 7.
Ah.
I believe. Oh, sorry, 13 or 14.
No, it's 13 or 14. So it's 1, 2, 3, 7 or 1, 2, 4, 7, but we don't know which.
And annoyingly, this being a 3 is sort of the opposite universe. So if this is 1, 2, 3, 7, that's when this is a 6. Okay. Unfortunate.
Ron says, does row 1, column 8 see a virtual triple of 4, 5, 6? Oof. Let's see. Row 1, column 8.
Because there is a 4, 5, 6 in here, right? Depending on, I guess, sorry, there's only two options. What are the two options for what goes in here? So it's 13 or 14. So this is a
Yeah, we
4,
should probably-
5, 9. And if
Right, and the 3 or the 4 in that goes in row 1. I think. No, sorry. That's not right.
Yeah, and the sadly the 4 in this cage doesn't seem to overlap with the 4 in that cage, I don't think. And sorry, but there's an 8 here as well, and so the 8 needs to go with 5 or 6.
Right.
And 8 for what it's worth. Okay, so yeah, so there's always a 4 in one of that mess.
So 6, 8 would be 14. That would make row 1, column 3 a 3. And then 1, 2, 4, 7. Oh, that all works. Okay.
Oh God, I just saw the worst thing. If there's a 6 in here, it makes that digit a 3. But if there's a 6 in here, it makes that digit a 3.
Oh no. Wait.
Oh, okay. Yeah.
Through the medium of that cell.
Yeah.
So there can't be a 6 in here.
Right.
That is gnarly.
That's horrific.
Okay,
But-
so that
But it
means there's
resolves so much.
so there's no 5 in there. Not gnarly, sexy. Let's see. Okay, and so
These
this
are the
being
13.
5.
So the 4 cell is 1, 2, 3, 7.
Okay, so yeah, so this is 1, 2, 3,
6.
7, and that is a 6.
7's in row
No,
2.
these aren't 7. Yeah,
And we do another
and
60
that's-
dents.
Yeah.
Oh, yeah.
Yes, we do. Boop, boop, boop. Wop, 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 wop. Boop, 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 boop. Wop, 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 wop. Thank you, Zach. Thank you. And so that has become a 5. This has become
9.
not a 6. Let's remember. So what are my options again?
12
Now
or
this is
13. Or sorry, 12 or 14.
14. So that makes this. Oh, but this can't be a 7 because remember one of these two is 7, even though I got rid of it. So it's not 12. So that means this isn't a 9. So that's a 3. This is 14, which makes that a 9. Makes that a 6 and a 9, right?
Yep.
Okay, these aren't 3 and they're not 5 anymore. Because of the 5, 8 pair there. This is the last 1, 2, 3 for the row.
The 8 in green has to be
it's
in
not a 3, by the way. Yeah, sorry, and also because of that 3 there, the 3 in this row is up here, so these aren't 3. Okay, sorry, the 8 in row 2 has to be in green, is what you said? Yeah, do we know it's not? How do we know it's not in red?
Well, no, where's the 8 in green? It's there.
Yeah.
Oh, I see. Where's the 8 in green?
They can't join the 7.
Can't join the 7. Right. Okay, yes. Thank you. So there's an 8 here. Agree. So yeah, so the total here is 14. So yeah, we're looking for 2 digits that add to 7. Oh, so they have to be 1, 6. Because they can't be 3, 4, or 2, 5. If I did my math there, right?
I think that's right.
1, 6, 7, and so that makes that a 2.
And that's
which makes these an 8 and a 4.
Yep.
That checks out. Oops. So no 2 there. I can get rid of that 3. No 1 there. I can get rid of that 7. I can get rid of the 2s over here. Get rid of the 2 and the 4 there. So we've got to get rid of the 7 there. Okay, so I can ask where are 6 and 7 in this row. Oh no, I don't know that these aren't a 6-7 pair, darn it. I thought I knew that these weren't a 6-7 pair, but I don't think so.
Oh, they can't be, because then the sum would be way too high for that cage.
Oh yeah, right. Okay, yeah. So it is true what I was gonna say. This is not a 1, because yeah, if the 6 and 7 here, the minimum sum of this cage is 19, and this cage can't sum to 19. So there's a 1 down here, actually. So no 1 there, no 1 there.
And Jim says 1, 5 triple left row 3.
I agree with that as well.
Row 2, I guess. Yeah.
Let's see.
So does the 4 in row 3 have to be an orange? Or could it be a 4, 6 with a 1, 2, 3? That would be 16. Now that could work.
Seems plausible-ish to me. Okay. Now this can't be orange. Look at that. Because if this were orange, this would need to be a 3, 6, 9, and it can be none of them.
Very cool.
So now orange is this. It's not this. So now these can all join up together and be purple. Somehow I don't have a purple yet. Okay.
So I have an observation for row 2. If the red digits are a 3, 5 pair, we know that it's going to also get a 6 or 7 in row 3. So it's at least 3, 5, 6, 1, 2. And that's too high. Right? Oh, wait. I might be wrong. 1, 2, 3, 5, 6 is, it's 17. Never mind.
Oh, orange is
done,
by the way.
And you can make that other cell red.
And this is odd. And it's only 1 or 7.
Oh, it's got to be 7.
C's a 1, so it is a 7, making that a 7. Making these a 1, 6 pair. So these sums, for the record, are to
19?
Yeah, 19.
Yeah.
Agree. So now the 6 in row 3 is in this cage.
Right.
So there's a 6 there. This cell is red, by the way.
So we could put a border between row 6, column 4, and row 6, column 5, because one of them is red, the other isn't.
Correct. I like that. Row 9, column 7, 8, 9 must all go together. Right. If this is... Well, couldn't this be something and then have purple come over here? Not 100% sure on that. I think then purple would finish this way, right? So if purple takes this cell, then this is the last 3, 6, 9, which would be a 9 for what it's worth, but that seems to work.
Oh, I have something. The 3-cell cage in orange, we said has to sum to 19, but it sees a 7 and it sees a 9.
I see.
So it has to have an 8 in it.
Yeah, so if it didn't have an 8, then it would be at most 654, which is way too small.
Which
So
results the total for red.
Is an 8, yes. Yeah. So now
16.
So now the total is 16, which means this is 1, 2, 3, 4, 6, because we know there's a 6 in it.
Mm-hmm.
So no 5.
Right, so no 5. So that is a 5 over there. In fairness, I think AFK understood the way this worked out like minutes ago, but I was having too hard a time visualizing it. So these are 2, 4, 6, and that one's not 6. Oh, and so then now there's a 2, 3, 4 triple in the row. Let's see. So no 1, no 3, no 2. Well, I guess technically I can leave the 6. Why not? Yeah. Okay, so now this is just a triple of
5, 8,
5, 8, 9. Mm-hmm. And that one's not a 9, at least. 5 or 8 seems plausible. So I was hoping that I'd know this wasn't red because it would put a 5, 8 pair in the column, but that doesn't seem to be the case. Sadly.
Going back to the 19 cage in row 5, we actually know the 3 digits for it.
Because we've got to have 2 digits that add to 11.
Yeah.
And they can't be 2, 9, of course not 4, 7, or 3, 8. So they've got to be 5, 6.
Yeah, so it's 5, 6, 8.
Okay, and so that makes that a 9 immediately. And now this is the other ones, which are 1, 2, 3, and 4. Mm-hmm. I believe. Oh, that 9 has put a 4 there and a 9 there. We have corner marked a 4 here now. These digits are 1, 2, 3, 4 for the row, and the 4 is definitely over here. Oh boy, we're really there's probably got to be an 8 in this cage, right? What's the smallest this can reasonably, because a 7, 9, 5, maybe there could be a like 6. Otherwise the total would have to be, yeah, the total, if we don't put an 8 in this cage, the maximum total of this cage is 10. And I can't, I could make 5 cells sum to 20, I suppose. Yeah. Never mind. I was thinking it was 6. Okay, never mind. It might be okay.
Carl is saying 7, 7 can't be 9, so purple can't take the 3-cell cage.
Yes, that is beautiful. Beautiful. Yes, so if purple took that, then this would be the last cell, and it would be the last one of those. It would be a 9. So purple does not take that. And so therefore purple needs to start taking stuff down here. Purple still needs a minimum of 3 more cells. So that actually forces purple to take all of these cells. Because as soon as it takes any cells down here, it's going to block off the rest of that corner.
Why couldn't it take 7, 7 instead of 9, 7?
Yeah, it takes 9, 8, and 9, 9.
This isn't 9 cells. This is 8 cells.
Oh.
That's so okay. My point is it takes one of those two.
Gotcha.
Let's see. KNT says blue is minimum 14 because 7 cells sum to at least 28. So yeah, so it's 14 and it can't, minimum 14, and it can't be 15 and it can't be 16. So we've got some
minimum
restrictions.
17.
Unless it is 14.
No, we've already used 14 in green.
Oh, right. Green is 14. Okay, green is 14. Okay, right. So yeah. So this is min 17. So it has to be 17 and that has to be 8. Otherwise, we won't get there. Right? Because we said minimum 17. That's the maximum it could possibly be. Do we agree with that, Math?
Let's see. It can't be 12, right?
No, because of KNT's argument that 7 cells together add to a minimum of 28.
Okay. Yes, that checks out then.
Okay, so that's a 5. That's a 1. Very nice. Very nicely spotted. So these need to add to 17 without using a 2, 3, 4, or 8. So
they've got to
therefore,
have a 1
these need to have a 1, right? Because otherwise the minimum is 5, 6, 7, which is too big. Especially given they're not going to have a 2, 3, or 4 in them, I suppose. So this is a 1 and 2 things that add to 16. So it's 1, 7, 9. So we've got that. So this is a triple of 5, 6, and 8.
And blue
right?
still needs 5 and 6.
Okay, that one can't be 5. That one can't be 5. And that one is 5. So that one's not red. So that one is red.
And it's got to be 8.
And it has to be 8, correct. And so that is a 6, despite my protestations to the contrary earlier. This is now a triple of 1, 2, and 4.
Yeah,
okay, so yeah, so this can't be 1 because then the sum would be 7. If this is 2, actually 2 is just barely possible.
1, 3, 4.
No, it's not possible because if this is 2, these are a 1, 4 pair, but you need both the 1 and the 4 in the cage. So yeah, so this can't be 2, but it's a little sneaky because this cage would have to be 1, 3, 4, except that would also be 1 or 4. So that is a 4.
So
and the total is
10.
10.
And so that's a 2. Does it have to be 2, 3, 5, or could it be 1, 2, 7? No, it can't be 1, 2, 7. Yeah, it's got to be a 2, 3, 5.
Yeah, so these sum to a minimum of 21, I guess, is yeah, so the right, so they sum to 21 or 22. Yeah, so it seems like 2, 3, 5 it has to be. Yeah, I guess I would first prove there has to be a 3 in here because if there's not, then the sum is too big. And then I guess if I don't then use the 5, then the sum is too big because of the 6. So yeah, I think that checks out. Oh, I guess here was the way to do it. These cells sum to a minimum of 21.
Yeah.
If they sum to 22 instead, there wouldn't be a 6 in them because they would be 1, 2, 3, 5, 1, 2, 3, 4, 5, 7. And there is a 6 in them. So they can only sum to 21. And therefore that's a 1 there. There we go. Okay, so that means these are from 7, 8, 9. And that one's not a 7. That one's not a 9. The last of these is also from 7, 8, 9. This 5
where does
probably blue, actually.
Where does what?
Purple get its 9?
Yeah, okay, yeah. Purple needs a 9, and it's not coming from either of these cells. So therefore that's a 9.
Or you could...
And also a good spot from David that the 3, 5 sudokus. So that's a 4 and a 6. And a 1, 8, 4, 6, 5. Very good. Oh, and that 5 actually sudokus as well. 8 and 5, making that a 7. Okay, so now the digit I need is an 8, so it can't go there. So now the last purple digit is there and is an 8. Okay, so now these at least are all joined together in the happy family. Okay, so if yellow doesn't take this 3-cell cage, then yellow ends up getting corralled into taking this 2-cell cage, which is maybe okay. I don't love it. Let's see. I'm going to just pencil mark these real quick. Yeah, so there's definitely a 1 there. And there's definitely a 6 in these cells for whatever it's worth. Can there be a 6 and a 7? If there's a 6 and a 7 here, then that's 13 plus 1 is 14. We've used that. Or 13 plus 3 is 16. We've used that. So there can't also be a 7 in these cells. I did that right? 13 plus 1 is 14. 13 plus 3 is 17. Yeah. Okay, so that means the 7 is there. Which then assuredly does something. So that is not a 2. So yeah, so one of those is a 2. Okay, maybe it did not do as much as I had fantasized about.
We might be, yeah, we could probably do more with the Audi in that yellow cage because it's a 1, 2, 3, 6 quad.
Yes. Okay, that's very good. Okay, so 1, 2, 3, 6 add to 12.
Like it can't be a 1, 3, 6 because then we'd have another 10 cage.
Right, we've already used 10, so that can't be a 2. Yep, so okay, so these are a 1, 3 pair, so that actually makes that a 2 and a 3, which makes that a 6 and a 2. So yeah, so it is 9 or 11. David did the math there very elegantly. Okay, so if this were 9, it certainly couldn't take the 3-cell cage. In fact, if this is 9, I don't think I can even take the 2-cell cage, right? Because if this is 9, what 2-cell? Oh no, I still have 4, 5 left. Dagnammit, I could still make this 4, 5 in that instance. Grumble, because this 5 could be blue.
Yeah.
If this were 11, if this is 11, in no case can this yellow take this because of the argument from before about the 22. If the yellow is 11 and it takes this, then that's a 6-cell sum to 22, which does not have a 6 in it, and this does. So this is always the last region by, funnily enough, exactly the argument that we have made previously.
Yellow has to get out.
Yellow does have to get out through this this thing, and so now this does indeed have to be 4, 5. Oh, sorry, no, this could be the sum could still be 11, but we still get some green coming out over here. Okay, yeah, so this gets one more cell.
I think it needs to be 4, 5 or 4, 7, so the 4 is placed.
Right? Okay, so this is right. So if it's 9, it's 4, 5, and if it's 11, yeah, it's not 2, 9, 3, 8, or 5, 6. So yeah, it's always 4, 7, and that's always the 4. And that is the 5 or 7. Good spot there on that math. That's a 1, 2, 3 triple in the column for what it's worth. So that's not a 1. And this is a 5, 7, or a 9 by the column, and it's not a 7 or a 9 by the row. So this is only a 5. This is a weird naked single, I believe. It's not 1, 2. Let me just double check. It's not 1, 2, 3, 4. And it's not 6, 7, 8, or 9. Okay, it really is a 5. I was wondering that as well to AFK. 9. Okay, so now the sum is 11, so that makes that a 3 and a 1 and a 5 and a 3. Okay, so now I can maybe write in the rest of these digits. Okay, this is a naked or single 9 because there's already a 6 in here, and likewise this is an 8. So that's a 6 and a 5. That's a 7 and a 9.
Okay, blue has to get its 6 in row 7.
Yep, so yeah, so blue needs to gain 2 more cells. And so and those need to be a 5 and a 6. And so this is the only available 6. And now, it's certainly going to take one of those 5s. Oh, actually, yeah,
we know which.
Green, actually, if you think about it the other way, green can't take a second 5. So green actually has to take this somewhat silly shape. And so that forces that to be blue, which then forces that to be yellow, and then everything is done. Well, not everything is done, but many things are done.
You missed a border.
Oh, no. And I didn't do the border around the outside either.
And between yellow and green.
Oh. I better quit while I'm ahead. Yellow and green. Yes, there we go. Excellent. Okay, so now we can just pencil mark green and hope as the classic. Okay, so that is a 1, a 7, an 8, a 9. Let's see. Let's see. 7, 8, 3, 1, 3, 1, 2, 3, 1, 7. Let's see. That 4, 6 pair makes that a 2. That 4, 6 pair makes that a 1. Let's see. That is not a 3. Okay, so we really do have a deadly pattern to resolve. I was curious if we are actually really going to need these cages down here, and I think the answer is yes, we actually really do need them because we have a deadly pattern.
Yeah. Well, the 2-cell cage can't be 11 or 13, so it's got to be a 12 with a 3 in it.
That will do, and so that has to be a 4.
And that does it.
6, 4, 4, 3, 2, 4. Yeah, that was very lovely. I enjoyed that quite a bit.
That was kind of amazing.
Yeah.
Very nice.
Really impressive setting.
Yeah, I quite enjoyed that. Yeah, the one spot here was a little iffy, but I really loved all of the rest of it. And that spot wasn't so bad. It was at least clear I was supposed to be thinking about what was happening with the 3, 6, 9. So I didn't feel too bad about it once I saw that I was supposed to pay attention to it. Alrighty, well, do you have time to do another puzzle?
Oh, yeah.
This has been more expedient than I anticipated when I looked at the puzzles.
I guess I wonder why this is called Mafia. Because it's killing.
Yeah, that isn't. Yeah, I guess maybe because of that. Yeah, I admit when I only read the title and I was wondering.
It's a bunch of killers getting together.
Right.
Yeah, I guess so. It did happen that every region had at least 2 cages, but I guess we definitely did not need to know that. Ben in chat is asking about the mark button. There is a script by Chameleon. If you hop on the zetamath Discord, link down below, I think, right, Tristan?
Yeah, I think it's pinned. I can check.
Then it is pinned there, or if you just ask, someone will link you. But it's a thing you have to install through Tamper Monkey. But it is well worth installing, I believe. Yeah, hacker stuffs in short. Yeah, it is definitely a feature that I will continue to beg Sven to implement because it is the question I get asked the most. So I think that Sven always very carefully decides what features to add to Sudoku Pad based on demand. But I think the amount of people who ask me how to get the mark button makes it clear that that is a worthwhile feature. Alrighty, shall we take a quick break?
All right.
Sounds good.
We will be right back. Welcome back. We are here with this Doomdiat puzzle. Let's see.
Have a sudoku. So each square is the center of a 3x3 box. Fill the grid with the digits 1 through 9, such that digits do not repeat in any row, column, or box. A digit in a circle must equal the sum of the digits along its arrows, if allowed by other rules. Wait, sorry, no, I skipped a line. A digit in a circle must equal the sum of the digits on its attached arrow. Digits may repeat along the arrow if allowed by other rules. And then crop keep it. Are we putting only one digit per cell? I think we're putting only one digit per cell. Is that right?
Is there
okay, so this isn't really a sudoku.
Is there? I mean, it's sort of. What are the squares?
They're the centers of boxes. So this is a 3x3 box.
Oh, got it.
And yeah, I don't know if this will
I had sort of interpreted that as every cell in the puzzle is the center of a 3x3 box, and I was very confused.
That was also my first reading, but I eventually got there.
Yeah. Would it be helpful to color each of those regions with like overlapping colors, or is that going to get annoying?
I mean, I don't think it will hurt to at least do it to sort of start and think about stuff like the fact that because of the overlap, these 3 digits on the arrow are the same as these 3 digits. So 2 of these digits are consecutive, which is like a little bit weird. But also, if I now do this, now these 3 are the same as those 3. And so 2 of these are in a ratio of 2 to 1. And it has to be these 2 because I can't have a 2 to 1 ratio of the circle with something, because then that would appear twice. So there's like a black dot between these 2, and this is therefore 3, 6, or 9.
That's interesting.
3, 6, 9 coming back from the previous.
The making a return. Okay, and so and these 2 are so these are 1, 2, 2, 4, or so these are 1, 2, 4, or 3, 6. Yep. So these are 1, 2, 4, or 3, 6.
And 3, 6, 9 goes in row 1, column 1, as Nell points out.
The 3, 6, 9 goes in row 1, column 1, right? Because of that. Yep, exactly. Which is quite interesting. So
and so that 3, 6, 9 also has to go on the blue arrow somewhere.
Yep, correct. So this could be 9, 8, 1, right? And it would be okay.
No, because then the 9 would be in the arrow circle.
Oh, right. The 9 would be there by spice. Okay, right. Yep. So so if this is a 9, that doesn't work. So this just can't be 9.
So that
can't be 9.
So
these aren't 3 or 6. So there's definitely a 2 on this this business, whatever it is. Okay, and so that means that this digit's never a 2. So it's not going 3, 2. So if this is a 3, it's going 3, 4, 5. If it's 6, it could be 6, 5, 4.
Or 7, 8.
Oh no, it can't be 6, 5, 4, because if this is a 6, then the digit then there's a 4 over here. So because if it's a 6, that means that these are 2, 4, because they add to 6. And then I can't use a 4 down here. So if this is a 6,
it's 6, 7, 8.
And it's 6, 7, 8, right. So
now if it were 3, 4, then it could either be arrow in blue could either be a 1, 3, 4 or a 3, 4, 7. And if it were a 6-7 on the white dot, then the arrow would have to be a 6-1-7.
Yep.
Oh, Todd has an excellent point that row 1, column 5, 6 has to be 4-8, and that forces a bunch of stuff just by what's in a
yes,
row.
beautiful. Yeah. So this is 4-8. Very good spot. So
that gets us
this
digits.
is 1, 2, and 1, 2 add to 3. And we get to bring out the 3 dance. Ba-boop, ba-doop. Woo! Ba-doop, ba-doop. Wow! Ba-doop, ba-doop. Wee! Ba-doop, 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 ba-doop. That was very gorgeous. I liked that a lot. Okay, so that makes that a 3, 4, 5. So these digits are a 6, 7, 8, 9. And so in particular, that's a 7 and that's a 7 with a 3 and a 4. That was not a 7.
Okay, yeah.
And we get to repeat this whole thing in the lower right corner. Which is probably about where we're at right now.
Let's see. Yeah, so I know this number is at least 4. So I know this number is at least 5. Oh, let me just start easily. This can't be a 4 because 4 is 1 plus 3, and there's already a 3 in the row. This is an 8 and a 4. And so this is 1, 7, or 2, 6. But this number is at least 5 because this number is big. 5, 6, or 9 are the options.
Mm-hmm.
5, it would be 4 and 1, which would put a 2 down there, but that all seems okay to me. Let's see.
So
maybe
by
we should...
our...
No.
Oh.
This can't sum to 5 because these digits... Oh, no, sorry. I thought they were going here. They're not going here. They're going there.
3 has to be in one of these cells by our boxes, and this 3.
Yeah.
Yes.
So
yes.
This 3 has to go down here.
So these are from 2, 3, 4.
Oh, now, let's see. Could it be... Yeah.
And 4 has to go in one of these 2 cells.
Well, it's not going in that one. 4 is going in...
Yeah.
Yeah, okay, yes. So 4, by the equivalence of this set of 3, 4 is going in the bottom row, but 4 doesn't go in either of those 2, so 4 actually goes there, which actually makes that 4 and 3.
So it's no
which now means this certainly isn't 5, and it's certainly not 6 either, so this is a 9, and that's a 6. Placing the 9 there. No 6 there, so no 2 there.
So now we know in column 3, we have a 6, 4 at the bottom.
Column 3, we've got a 6, 4 at the bottom.
Because
Can you...
Yes,
because of the equivalence of that column and that column. So so these are 4, 6, and that one is a 6, that one's a 4, so that's a 5, because what else is it going to be? It is an 8 and a 6. Okay, I'd better have a 1 on this arrow, I suspect, or I'm going to be a minimum... Actually, maybe not. It could be 2, 6, I think.
It can't be... No, it could be 2, 6.
Yeah, we can remove the color and put the color at the bottom, since that's now what matters. Per Ron's suggestion.
For row 5, column 1, that's got to be a 1 or a 2. Because there's a 1, 2 pair in column 2.
2 pair in column 2.
So yeah, actually row 5, column 2 is a 7 or 8, right?
Why does this have to be a 1 or a 2?
So row 5, column 2 sees 1, 2, 3, 4, 5, and 6. So it's got to be 7.
I see. Okay, got it. Okay, there we go. Okay. Sorry, I was trying to do an equivalence, and I was like, are you putting an equivalence where there's not a square, or am I not seeing a square that's there? But no, okay, so this makes this an 8 or a 9 for sure. Okay, and this digit's not 1, 2, could be 3, can't be 4, 5, 6, and then could be 7, 8, 9. Let's see, Todd says this is a naked single, which is interesting. Let's see, it's not 1, 2, 3. It's not 4, 5. It's not 6. It's not 7.
Oh, and 9 has purple and 9 already.
So oh yeah, 8. Purple. Yep. So it is a naked single 8. Got it. Okay, very nice. Let's see. What about this? This can be 1 or 2, maybe. Let's see. Can't be 3, 4, 5, 6, 7, 8, or 9. Yeah. So this is this is only
9
1 or
2. And Ron. No. A bunch of people.
9 is in one of these 2 cells, so it's not there. Is that what you're going to say?
Yeah. A bunch of people.
Yeah,
I was just trying to give credit.
Yeah, so these are from 1 to 9. But one of them's 9, so that makes this an 8, which makes that a 7 and a 1, which makes that a 2 and a 1, makes that a 2 and a 1. Let's see. So there's no 7 or 8 there. Okay, so there's a 2, 4, 6.
GDC has a great point that you have to put row 2, column 5 in purple somewhere.
Okay, I was just going to say that the 7 in yellow was placed here, which is a much more boring deduction. But I agree. So yeah, so this cell has to go into yellow, and it can only go there, is what you're saying, right?
No, row 2, column 5.
I mean, it is true that this cell goes there for sure, right?
Right.
Sure. So that still places the 9 there. Which makes that a 3. It means that this is the other 1, 2, which then makes that 2, 1, 1, 6, 2.
Wow.
Very nice. Clean and quick.
That was marked as a 3-star?
We're apparently just that good. We can certainly do another one if you want another one after that.
We would certainly have time for an easier 9x9, like a 2 or 3 star.
But yeah, that was very nice. I liked that.
Or we could just do some 6x6s and call it a day. However you want to do it.
I'm fine with either.
See, there's a quadruple puzzle in here. We could try the quadruple puzzle.
I love me some quads.
Okay,
in the bucket
by Allegem. I mean, it was on.
On the list. Gotcha.
Yeah.
Go ahead and load it up. Let's see.
Okay.
Meeting the quota.
Indeed. Let's see. So here we go. Okay, so normal Sudoku rules apply. Each digit in a circle appears at least once in the surrounding 4 cells. Okay, the intro said something about slingshots, but doesn't appear to be slingshots in this puzzle. So let's see. So we've got all of that. Okay, so let us do our typical search for relevant.
Row 3 and 4 and column 3 and 4, there's ones.
Okay, so okay, so row 3 and 4 and column 3 and 4, there's ones. Okay, so the 1 on this 1, 8 is in one of these 2 cells. Tristan, can you put the link in chat?
Already did.
Okay, people in chat were asking. Let's see. So that means the 1 on this quad is over in one of these 2 cells.
I mean, surely you could see that I already did.
Let's see.
The other 1, 8 quad in between rows 2 and 3. Same logic there.
2 and 3.
There's another 1, 8 quad in between rows 2 and 3.
There we go. Okay, yes.
Yeah. So
Oh, right, because there's a row here. Got it. Okay, right. So yeah, so there's a row here. So there's a one in one of those. Got it. Okay. Sorry, I had not I had not sort of mentally switched to the rows. I'm a little concerned. Let's see, if we put the one here, uh, yeah, I guess the point is we have like a jellyfish kind of thing on ones in columns 1, 2, 3, and 4, and that we know we need ones in all of those
And
spots.
the other group of ones as well, because through the medium of box 2.
Right. There's not a one in one of those two either, I guess. So actually, I know one of these two is one as well. I can go ahead and say by that sort of corner marked one. Okay, so if this cell is a one, then what we immediately get is that that cell's a one, which makes that cell a one, which makes that cell a one. So that's sort of one possible universe.
I think that messes up the 1-2 quad clue.
Yes, that doesn't work because now this clue has no ones on it because that clue and that clue kill it. So this can't actually be one, is the point. Because again, if that's one, then that's one, and that's one, and now, oops, sorry,
Yep,
and then that's one, and now that sort of wipes this out. So this is not one, that's one, and we get to do a one dance. Woo! 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 If Ranks were here, I think he would use a word like alternating inference chain or something for that deduction that I don't know. Okay, and now that being a one conveniently doesn't do anything, I think.
We do a little bit more with the 1, 3, and 2.
We can, that cell you have highlighted, I think we can also say is not a one.
So it would make that a one and make that a one.
Right, that messes with 3.
Oh, that messes this quad up. Right. Exactly. It messes this quad up. Okay, so that can't be a one. So that's a one. Oops. And we can get rid of the yellow, get rid of that. Okay. Okay, so one of these two is definitely a one. I think that's just a straight up kite, but I'm not sure. But one of these two is a one, because if neither of them is one, these aren't. So that means this cell's definitely not a one when it comes time to look at this. So I'm trying to sort of make sense of what that's going to say about these 1-2s.
For the 1-3 clue, the one has to be in row 5. Because if it's in row 4, it's going to mess with the 1-3-8 and the 1-2 clues.
1-3-8. Yes. Okay, yeah. So yeah, that cell's definitely not a one because it breaks.
The 1-3-8.
Couldn't the 1-3-8's one just be there then?
Right, but then the 1-2 clue.
The 1-2 clue doesn't have a one.
Right. Okay, yeah, right. So yeah, these two together sort of gray out, right? They gray out that cell.
Isaiah asking when this puzzle was set. It was published in May.
Gray out that. So yeah, so we have sort of our one of these is a one and one of these is a one. Kind of pairs. So one of those is a one, one of these is a one, although I don't know. Since there's nothing else about ones anywhere else in the puzzle, I suspect we're going to run out of useful things to say about ones.
One in box and one in box 8.
Do I know for sure this isn't a one?
Yeah, because there's a one in row 2.
Oh, yes, I do. Yes. Okay. No, never mind.
Yeah.
So yeah, I was trying to think about one in this box. Yeah, and so one in this box definitely is actually in one of those two cells.
So one in box 6 and one in box 8 are limited now. They have to be in row 6 and column 6.
Yes. So right, because these two form so now again, so this is a 1, 2, 4, 5 is what you're saying.
Yep.
Because one has gotten sort of jumped into here. So there's a 1 in here. And in particular, that means there's a 6 in one of these two cells. Let's see. Are we so lucky that we get a similar thing over here? Yes, exactly the same thing. 1, 3, 4, 5. No 1 there, and so that puts a 7 over here. Are we setting up a really bizarre naked single on this cell? That would be impressive.
We have a cool, in box 9, we have a cool 2, 3, 4, 5 quadruple, and we know that 3s are so helps with the other aspects of those two quads, like now there can't be a 3 in column 6 of those two.
Right. So yeah, there's a 3 here and a 2 here. So now these can't be 3 and these can't be 2 is what you're saying. Let's see. Okay, so these can't be 7 either. But I guess maybe that's not super exciting. I mean, they're down to 4 options, but I don't necessarily want to pencil mark that immediately. Let's see. I'm trying to figure out what I'm supposed to do with the 7 and 6 marks. Or yeah, the 7 and 6 marks here. I mean, maybe they're vaguely supposed to be telling me I'm supposed to look at this 6, 7, but I don't know what to do with this 6, 7 immediately. I can probably ungray this for now.
I guess the 7 quad in box 9 is limited to the places you don't have marked, although those aren't lined up, so
yeah. Let's see this.
But I do feel like we're supposed to be working 6 and 7s back around.
So neither of those can be 6 for what it's worth. So one of these two is 6. I don't know how great that is. I mean, I guess I might as well mark that this is from 6, 7, 8, 9 for sure. Just because it sees 1, 2, 3, 4, 5. But one of these is a 6. But I don't think that immediately tells me anything that I can find.
So the 6, 7 quad, I mean, this isn't super helpful, but the 6 can't be, or actually the 6 and the 7 can't be in 3, 3.
Right.
Because
Yep, this can't be 6 or 7, so they're
doesn't quite do enough though.
Yeah, if this also couldn't be 6 or 7, or if this had to be 6 or 7, it would begin to do something, which is maybe there's some way we can get at that. The 6, 7, and just these 3
is
cells.
6 or 7, then that looks into box 6 or box 8.
Yeah, so if this is 6, it makes that a 6, 7, and if it's 7, it makes that a 6, 7.
Yeah.
So yeah, so if that's a 6, that's a 6 is the upshot of that, I think. If I kept track of that correctly. And I think if this is a 7, that's a 7 for the same reason, just by chasing the pairs around there.
No, that's not very helpful.
Yeah, there's also some weird parity on 4s and 5s that I may be supposed to think about in conjunction with these things, but I don't really see how to make it tick. Let's see. Is there any digit we can fantasize about shoving onto one of these 2 3-cell quads?
Both of those clues. Oh, go ahead.
Oh no, sorry. You go ahead.
No, I was just going to say those. Both of those quad clues have 1 and 8 in them. Does one of them have to have the 8 for box 1? Probably not. Let's see. What is chat saying? Emma says row 7, column 4 is not 5, nor is row 4, column 7.
Nor is row 4, column 7 a 4.
Oh, a 4. Okay. Why is that not a 5? Oh, because it.
I think this being a 5 is fine, because then you could just put a 5 down here, right?
Yeah, and then that would put a 5 in at the end of row 6. That seems okay. Oh, a very unhelpful point is that row 6, column 6 can't be 1, 4, or 5, I think.
Can't be 1, 4, or 5. Yeah, because yeah, if it was, it would repeat that digit in this box. So
Right.
2, 3, 6, 7, 8, 9.
Okay, let's see. Eckbert says the 8 in 1, 2, 8 clue can't be in box 1.
Ah, yes. Okay, so that would force 8 to be in one of these 2 cells, and it would break this 1, 8 clue.
Yeah.
Yeah.
So yeah, so the
Oh, we could
So
probably do the same for the 1 through 8 clue as well.
So we know one of
Yeah.
these cells is an 8 for sure.
Yes.
Now, could the 1, 3, 8 clue have the 8 in box 1? I think that also messes up the 1, 8 clue.
Yes, because again, yeah. Now actually, this 8 is just placed because this 8 corner mark actually places that 8, right?
Yeah.
Yeah.
So
Hey,
now
another
definitely one of
digit.
these is an 8.
And then the 1, 8 clue at the towards the bottom between columns 2 and 3.
Its 8 is also placed.
Yeah, there's some really cool symmetry here.
Yeah, this is definitely a carefully thought out puzzle.
Let's see, Carl says a 7, 8 pair in box 8.
Yes, okay. So now that's going to do things with the 6. Because we had said previously that if that was a 6, it was going to place a 6 here. So now that can't be a 6. Because if this is a 6, that's a 6, and that crisscrosses this whole box.
So the 6 in the 6, 7 quad is placed. It's got to be in 4, column 3 now. Because of there's a 4, 6 clue
The 4, 6 quad in box 1.
Yeah, so it's not here, it's not there.
But what about
also because the 6 quad in box 8 forces
Oh
it.
yes, looks up at that.
Looks
right,
up at
right.
that.
So, yes.
Very nice. Very nice.
Right. Okay, so yeah, so we've got that. Let's see. Laura says this is only 2, 3, 9.
Oh. Yeah, because 4, 5, 6, and 7 are.
Yeah, 4, 5, 6, and 7 are gone. 1 is gone.
And 8 is in the row.
Yep. So one of these 2 is definitely a 7. I guess that's not necessarily immediately exciting. Oh yeah, the 8 is placed on the 6 now because of the corner mark.
Hmm.
Emma points out, so that's symmetrical.
So
That makes
there's a
sense.
7
So
there.
there's a 7 up here, which places, the
places the
7 on
7.
this quad.
Okay.
So the 5, 7
Has a
is
7
there.
there.
I guess the 4, 6 is there. Or the 6 on the 4, 6 is there as well. 2 joins the 6, Daniel points out, because of this 2 looking across, and 3 joins the 7 in this box.
Nice.
This is quite something in terms of setting.
This is really meticulously constructed.
Yeah.
Carl points out that yellow is now a 1-2 pair.
Right. Because of the 2 looking up. So this is a 1-2 pair.
We do the same. Yep. Orange is 1-3 pair now.
Yep. Absolutely.
Yeah. It's constantly like a 2-for-1 deal with these steps.
Yeah. It's so symmetrical that it almost has to be.
Oh yeah. The 3 in the 1-3-8 clue
is now up here.
Out.
So it's not there in particular.
And the 2 in the 1-2-8 is also in box 1.
So that makes this a 9. Yep.
Nice.
Very nice. Let's see. Unfortunately, I don't think we have any 9s anywhere in this. Oh no, sorry, there is a 9. There's a 9 here. Oh, and a 9 there. Okay, sorry. When I said there weren't any 9s, I was off by a significant number of 9s. Let's see. I also realize I know one of these is 9, so I actually know that's not 9. While I'm at it, so this is always a 6 or a 7. I also know that one of these is 2, but I don't know that gets me anything.
So 9 in box 8. That's not great, but I mean it's in row 7, so now the 9 in box 7 is limited to 2 cells.
Yeah. So one of those is a 9. I agree. See, Ambrose asks what digit this can be.
Can't be 1, 2, 3, 4, 5, 6, 7, or 9. It's an 8.
Yep.
It's a naked 8. Wow.
Nice.
So that places these 2 8s, which places these 2 9s.
Nice.
It's pretty nice.
9 in box 3 is also limited to 2 cells.
Yep.
In row 1.
So yep. Agree. Let's see. I kind of curious, like, is this cell very restricted? Can't be 1, can't be 2, can't be 3.
Oh, 8's placed in...
Can't be 4.
8 is placed in box 5.
Or 7. Can't be 8, can't be 9. So this cell's only 5 or 7 for what it's worth. You are looking at 8 in box 5.
8 in box 5. 7, 8
yeah, because the 6, 8, 7, 8. Yeah, okay, so that is an 8, and so therefore that is a 6.
And now we know 7 goes in box 9.
Yes, we do.
All right.
Makes that a 3 and a 7. Makes that an 8 and a 7. Now these are 1, 8, and 9, I believe.
Yep.
And that one's not an 8.
Row 5, column 5 is 4, 5, or 6.
Okay.
Oh, 4 or 5, actually.
Yep.
Yes, because there's a 6, 8 pair looking at it.
Daniel says 7 in box 7.
Oh, 6 is just placed in box 5. points out Egbert.
7 in box 7 is placed, which actually goes back and makes this a naked single. So that's now a 5. And now that's the 7 for this 5-7 oople. We probably should actually mark these as well, just while we're at it. Because like this one can't be 2, for example, and that one can't be 2.
We can do a bunch more than that. We can place 6 in box 5. It's in row 6, column 5.
6 in box 5, we can. Right, 6 by, right, 6 by corner mark, right? We had corner marked 6 in this box, and so it is there now. It's 4, 5, or 9. I really did know this cell wasn't 6, right? I'm pretty sure I knew that somehow.
Yeah, it's because of the 4-6 quad.
Right. Yes. Very nice. Okay, yes. Okay, speaking of 4, actually, this cell isn't 4.
Because of the 4-6 quad.
Yes.
And now the 3-1-3-8 quad.
Yep.
4-1. Oh wait, no. What am I saying?
No, you just placed it. Yeah.
Yeah.
So yeah, there's a 1 over here. Let's see. Yeah, there's a 2 and 1 of myriad position. Let's see. Are there going to be random naked singles floating around here? Because we've already got a 2 in the box. Let's see. Maybe not. No, we've got sort of our 3, 4, 5 sort of coming down this column is what's left. Let's see. 6 in box 2 in 2 places. I agree.
And
five in box 4 is in row 6. That's very, very important. Daniel points this out.
Good spot from Daniel. Yes,
that's huge.
So that 5 looks over there. That makes these a 1, 4, which makes those a 2, 5, which makes these a 3, 4.
Places 5 in row 8, column 3.
Means none of those are 5.
Places 5 in row 8, column 3. On the 5 quad.
5 quad, yes, got it, yes.
Here, and
so
places 5
5
here.
1, 5, 9. 9. You've circled the wrong cell, but I'll.
Oh no, I'm circling for another reason.
Oh, you're circling for another reason. Oh,
that's a 7.
That's a 7. Yeah. Let's see. It is not. Is it a naked single?
It's the only place for 7 in the box.
Okay.
Oh, yep.
Yes. Okay. Yes. Okay. Okay. What about this row?
2, 3, 9.
Because these aren't 4 and they're not 1 either. So yeah, 2, 3, 9.
And the 2 would be in column 4.
Right.
Yes.
That is a 2-6 pair looking at it.
Right. Yes. Oh, this 9 seems to have placed a 9 up here, by the way. That might be the last 9. It was not the last 9. Yes, the 4 in box 3, Ron points out, because the 1, 4 pair here places that 4. Making that a 1 and a 4. Also, is this really just a 9, 8 and 1, 6 and 8? Sure is just an... Oh, no, sorry. One of those 2's a 9. Never mind, sorry. What are these? These are 2, 5, 9, I suppose. So that's a naked single of some description. It's not a 2, a 5, or a 3. So it's a 7. Okay, what about these digits? That one, I guess, has to be a 2 or a 5, and it's not a 5, so that is a 2. So that will look down, make that a 5, and that a 2. My typing is good all of a sudden. 3, 3, 5, 6. Oh, that 2 looks over here, makes that a 4.
So
We've
that's a
made
2.
our 4, 6 happy.
In column 2, we have a 2, 4 pair.
Yes. Okay, 2, 4 pair.
That's a 2.
Why?
2, 6 pair in column 4.
6 pair. Right. So I need to put a 2 on this somewhere, right? Okay,
No.
so I need to put a 1 on it somewhere, so that's a 1, and so we get our various things sort of hopping around. Let's see, and now craziness ensues as we proceed to fill in. And so now I think if we actually just hit the mark button, I think now everything will fill itself in. 2, 7, 5, 4, 2, 6. Oops, I just filled in a random digit. It happened to be the right digit, but it was not intentional. Why is it not think I'm done? Oh, I really wasn't done. That's why I didn't think I was done. Excellent. That was very very carefully constructed, I presume. Either that or they just placed quadruples at random until a solver said it was unique. But I feel like it's very unlikely that that is what happened based on how that solved.
Yeah, I'm gonna say that's probably my favorite pure quad Sudoku that I've done.
That was
Did you do
really
that Clover
impressive.
one? Clover has a pure quad that's just magical.
Oh yeah.
Yeah, I bet I can find it in the spreadsheet for you later if you remind me. But it has a break-in that is like no other. But I know she had the idea and then took her dozens of hours to make it work. Which this puzzle may well have as well, given how this all sort of worked out. But very nice.
Do we want to do a 6x6 to wrap up?
We can do a 6x6 to wrap up.
Codex is Daniel's 6x6 is very beautiful.
Okay, let's do that. Let's see. A lot of regional variance one.
Yeah, although it's also a follow-up to one he posted shortly
let's see.
before that.
No, we did Bad Decaf Cafe.
No,
regional accents. There we go.
Regional accents.
We haven't done this one yet. Okay. Let us have a look at this puzzle. All right, so I have normal Sudoku rules, normal XV rules with no negative constraint, even squares and odd circles. Each line, distinguished by a color and thickness, is a region parity line. Region borders split the line into segments. Along each segment, the sum of the digits has the same parity as the sum of other segments on the line. If a line re-enters a region, each segment is considered independently. And so we get that. Okay. So the sums have the same parity. Okay. So these two digits are odd, I see, because they are a sum of an even and odd number.
Okay.
Also, let's start our coloring while we can. Also the X is 4, 6 because it's a 6x6, and I should remember that. Also, actually, it's probably the 6 probably doesn't go on the side with the V. So probably we get that.
Okay.
Okay. All right. So these have an even sum just by the columns line, and that is odd. So those have an odd sum. So because the sum of everything is odd, that means this must be even, right? So it's 2.
The other blue takes up all of box 2, so that's odd, which makes row 5, column 6 odd.
Yeah, so that is I guess this could be a 2 or a 6. Never mind. Okay, but these are all odd, which makes that even. Right. So you're saying the sum here is odd. Yes, so that is odd. I agree.
And then we also have the parity of row 3, column 5.
Right, because these are one of each no matter what, I guess is the point, right?
I was saying something else, but yes.
Yeah, so those are one of each no matter what, so therefore this is even. So these are both even or both odd. Sorry, you were saying something about, you were saying something about this cell being even for sure. And therefore this cell's also even for sure for the same reason, which makes that orange. This had better be even, given that we have even plus blank equals even. So we've got some oranges happening there.
Row 3, column 1, we know the parity of.
Yes. And so that gives us the rest of the row, which gives us the rest of this box. Sadly,
So
I think I already knew that this was going to be an odd even pair.
Yeah.
We know the digits in the other B.
Know the digits in the other what?
Sorry, the B clue at the row 6.
Yes. Okay. Yes, we should probably pay attention to that. Yes. Okay. So yeah. So this is a 2 and a 3. I was looking for like a whisper line that was shaped like a V and not quite seeing it, having completely forgotten about the existence of this kind of V clue. So this is now just a 4, and that's a 2. That's a 6. So that's a 4. Let's see, that's a 4.
Emma says row 5, 4 and row 6, 4 are the same parity.
Right, because this is an odd and an even, and so it's no matter how you stack them, they're either because basically the sum of these is even, and so the sum of these is even, so they're the same parity, and hence that parity is even. Very good spot, Emma.
Very nice.
And very, very clever setting there. So now that one's orange, and that one is blue. Dot, dee, dot, dee, dot. These are orange. That is blue, and that is blue. And now we have a good coloring bit going. So that is a 1. So that is a 5 and a 3. Let's see. That's a 1 and a 5 just by playing around that box. So that's a 4. That's a 3 by the row. That is a 3. So that's a 3. So that's a 3 and a 5 and a 1 and a 5 and a 1 and a 5. I didn't think I was going to finish the odds first, I'll be honest.
So
let's see. That is a 6. Is that the one you were going to say?
Yep.
And so that's a 4 and a 2 and a 6 and a 2 and a 6 and a 2.
Right.
Very nice. I quite enjoyed that one. Seems like a very weak clue. And I suppose it is a very weak clue, but it was still some very cool logic to sort of bounce that around. Very, very, very fun little 6x6 there.
Yeah.
Alrighty, well, we should probably wrap up there for today, but thank you everyone for hanging out. Thank you. Big thanks to Math Pesto for joining us today.
Thanks so much. I had a lot of fun.
Yes, I hope we'll have you back at some point. Yeah, it does feel like you could maybe do a meteor puzzle with it, Daniel. Although I feel like if you try to do a 9x9, it might get a little tricky because you would have you have to somehow sort out digits or something. But but yeah, it certainly has some potential as an interesting thing. What I actually thought was going to happen, I when I first read the rules, I thought it was going to be all of the things in a region have to be the same parity, and then when it crosses a border, it's then the other parity. But it turned out being sort of more spicy than that at the end of the day. See, Daniel thinks we should do the other one as well. We can do the other one.
Yeah, sure. It's
sure.
Free puzzle idea indeed. Okay, so I assume this is the same rules.
Yeah, same rules.
uh,
Odd even lots.
Okay, indicates the number of odd digits along the line, indicates the number of even digits along the line. Okay. So let's see. So how many even digits are along this line? It had better be 2, right? There'd better be 2 even digits along this line as well, which means that's also even. Wait, do I know that it's actually even? Sorry, it can't be 2, can it? Sorry, I'm assuming that this is the number of even digits and it is even, but it can't be 2, because then the sum wouldn't work. So it's got to be. So either all the digits are even, which is not possible because then this digit would be a 3, or there is 1 even on it because the sum of the whole line is even. So it has to be 1 is what it actually has to be. This one really does have to be 2. Do we agree?
Yes.
Okay, so this one really does have to be 2. Yeah, so that is also even, and that's even. Let's see, this line is enormous.
Yeah, that line.
But we know it's parity. It's even. The really long.
So now these have an even sum. So these have an even sum, which means these two have an odd sum, which means that digit is odd.
Yes.
And means these 4 have an even sum. So those 5 have an even sum. So that makes that odd. And then by the magic, that is odd as well through sort of the magic of the bluish line. Also, 1 is odd. That's all the odds in column 4, right?
Yep.
So these are even.
The column 3 line, that's 3 cells long. That can't be all odds because that would mess up the bottom of column 3 line.
Yeah, it can't be all evens either.
Sorry,
So this is an even and an odd summing. Sorry,
so
it's
row 2, column 3 is
2
odd,
odds
then.
and 1 even, right? Is what it's got to be.
Yeah. So row 2, column 3 is odd in particular. Oh,
I don't
sorry,
think that's true.
it doesn't have to be.
But that needs to be even because of that. So that makes that odd by the blue line, I think.
Yep.
Okay, and so now the blue line, we can just count the number of odds along this line. 1, 2, 3, 4.
Wait, row 3, column 3 is also.
So it's.
So that is odd.
Row 2, column 2 is a 1 because. Well.
Okay, yep, and then this one is a 5, right? Yeah, this is a 5 just by counting, which makes that a 3. Okay. Okay. This can't possibly be a 1 because there's 2 odds on that in this box, and there's 2 odds on it in this box. And there are 2 odds on it in this box. So this just is a 6.
That's very cute.
We can actually count it. Okay. Let's see. So yeah, this is an even odd pair. One of these is a 1. These are an even odd pair as well, if that is helpful. I don't think it is. I mean, the odd is a 5 for what it's worth. Oh, actually, that is worth something. These are an even odd pair. The odd is a 5. Now, where does the 5 go in box 2? It has to go there.
Nice.
I will take it. So one of those 2 is a 5. Unfortunately, not as useful there. Let's see. Daniel says no. I may have
Uh-oh.
Did I math wrong?
No,
Oh, yes, I
I
did
think
math
you.
wrong. No, I did math wrong. Because this is not a line. These are just two lines that
Oh.
camouflage as a
Oh wow,
line.
that looked like a
I see.
line.
Yeah, it did look like a line. So yeah, so actually, if I read this correctly, these two are the same parity,
Right.
and
So
they can't both be odd because there aren't two odd numbers that could go here. So they're both even.
there we go.
Uh, so those are both odd. That's even. Those are odd. That's
That's
even.
even.
Uh,
So row 4, column 2, we know the parity of.
uh,
Because we
do
have
we?
yeah, because the three other white cells are going to have an odd parity sum.
Oh, right. Sorry, yeah, I had not appreciated. Yeah, we know these sum to an odd number, and so they have to have one odd in them, and so the remaining odd goes there.
And we
Uh,
know both the lots on that line,
Mhm.
the even and the odd
uh,
lot.
yeah, so
That
the even is 2, right?
the
Sorry, the odd is 2,
the odd is
is what I
2,
meant
the
to say.
even is 3.
And then I made it orange just to make myself even more confused. So that is 4. The odd is 3, 5. So that's a 1 because it's the only available number.
Now the one in
Uh,
box 5.
1 in box 5 sure is there. Uh, let's see.
Now row 6 column 2 is going to be a 2, and those are both even.
Yeah, these are either both even or both odd, and they can't be both odd for lots of reasons. So they are both even. And that is indeed a 2. Uh, okay. And so right, so there's one more. That odd digit goes here in this box, so that digit's definitely odd, which makes that even. Because that odd digit is not 1, and it needs to go in this box somewhere.
Now we can do the rest of
So
columns.
that makes that 6 and that 4, and yeah, that's going to be orange. Uh, oh, the rest of column 3, we're going to say? Sorry, that.
No. Well, yeah, but also columns 1 and 2, we can do the parity of.
Yes, so that is blue and orange. Excellent. 5, 5, 6, 4, 6. Uh, excellent.
And now it's just Sudoku.
Yep. So that I know is orange.
It's a 1.
That I know is blue. It is a 1. That one's a 1. That one's a 3. This blue
That's
is
a
a
2.
2. So these are orange. So that is blue and that is blue. And so now we hopefully can fill in the digits. Let's see. So that is a 4 and a 6 and a 4 and a 2 and a 3 and a 5 and a 1 and a 5. There we go. Very nice. Uh, very nice pair of puzzles there. I do always like the odd lots kind of rules. I enjoy those quite a bit. But whoever knew that Zeta liked circles that count things, but I like circles that count things. Alrighty, well, thank you again for hanging out, Math Pesto. I hope to see you around soon. I also hope to continue doing your pencil puzzle hybrids. So I have been greatly enjoying those, especially this summer. Uh, we have done many of them. Although it's possible I did most of them while you were still busy and did not see all of them. But
I catch the VODs of them though, so it's all good.
that makes sense. Yeah. Well, I will continue to do those.
Remember how we used to do 8-hour streams?
I occasionally think that and then ask myself, how on earth did I do that?
Yeah, I mean, I'm even wondering how you do this twice a week, but
Yeah. Yeah, I do. Yeah, I do sometimes wonder that. And I sometimes think like maybe I'll do another 24-hour stream someday. And then I
oh,
think, oh
right.
God, 24 hours is a long time. Uh,
Yeah. And there have been a couple of people who have said I should get back to streaming. I really want to. And it's life stuff has been more complicated than I would like it to be. But I do plan to stream not a zero amount.
Well, you have begun streaming a not zero amount today by streaming. So
Yep.
There you go.
Thank you so much to Math Pesto for joining us. This was so much fun.
Absolutely.
Thanks to the chat for all the help.
Absolutely.
All right. Do you have anything you'd like to plug, Math Pesto?
I don't think so. This is my probably longest break from setting the past couple of weeks. I'm sure I'll have some stuff out later in the summer. So.
All right. Well,
you can plug a Twitter or a Patreon or a charity or something if you want. You can take advantage of that.
Yeah. I don't know. I'll have to think of that later. But yes.
Alrighty. Well, we'll give you ad time later.
Yep. Well, we look forward to seeing you in chat, Math Pesto, and we look forward to having you back on at some point.
Yeah. Thanks so much.
Thanks for watching, everyone.
Thanks, everyone.
Bye, everyone.
Bye for now, and we'll be back on Sunday.